There is a private theatre in every human head. It opens each morning in the hush before speech, in the small incandescent delight of noticing the color of coffee, the weight of a hand on a doorknob, the sudden taste of memory. That theatre is not merely a stage where events happen, it is the very fact of happening, the warm, unmistakable sense that something is being lived from the inside. We call that sense consciousness. To sit with the word for a few minutes is to realize that it names both the most ordinary thing and the most baffling mystery, ordinary because it is the texture of our waking life, baffling because when we try to explain how it arises from lungs, blood, and neurons our language feels inadequate. The question, what is consciousness, is insolent in its simplicity and generous in its demands. It forces us to move, simultaneously, into the deepest reaches of natural science and the strangest reaches of first-person experience. It asks us to map an inner geography that resists the usual cartography of explanation, subjective quality, the way things feel, the redness of red, the ache of loneliness, the taste of lemon. These are not easy items for an anatomy textbook to carry. From the first page of this book I want you to feel that tension, the human tendency to explain and the stubbornness of experience to remain what it is until explained. For centuries, thinkers approached the problem in two broad ways. Some took the route of introspection and philosophy, carefully describing experience, analyzing concepts, and asking what it would mean for a mental state to be more than a bundle of behaviors or brain events. Others adopted a pragmatic scientific strategy, find neural correlates, measure behavior, manipulate neural activity, and infer the functional architectures that support perception, attention, and decision. Both routes are essential, neither, by itself, fully dissolves the mystery. That is because consciousness sits at a junction where language about the world outward, third-person facts, and language about the world inward, first-person facts, cross and sometimes collide. One crucial distinction to hold gently is between two kinds of problems consciousness poses. There are the problems that seem tractable to the methods of cognitive science, how sensory information is transformed into a stable percept, how attention selects stimuli, how memory binds features across time. Call these the mechanics or the lazy problems. Then there is the deeper, more stubborn question, that hard problem, why and how do particular physical processes give rise to subjective experience at all? Why does the firing of neurons in a visual cortex produce a felt seeing, rather than an equivalent set of unconscious signal transformations? The phrasing is provocative but useful because it grounds our investigation. Some aspects of consciousness can be approached by tracing mechanisms, while others press us to ask what it means for a physical system to have an inner life. History is instructive because it shows how our metaphors shape our wonder. In the past, the soul or animating spirit served as the placeholder for subjective experience. With the rise of physiology and later of neuroscience, the metaphor shifted, the brain as machine, the mind as computation, conscious states as patterns of information processing. Each metaphor carries an intuition and each obscures something. The machine metaphors encourage explanation in terms of parts and functions, they make testable predictions. But they sometimes obscure the qualitative, felt side of experience. Meanwhile, more recent metaphors, like consciousness as an emergent property of integrated information, seek to bridge this gap by proposing formal measures that can, in principle, be connected to subjective reports. Consider, for a moment, a few empirical oddities that have shaped the modern debate. There are cases where the brain carries out complex processing without any corresponding conscious feeling. Blind sight patients, for example, can navigate around obstacles in what seems like an unconscious visual field. They can point to the location of a light even though they report seeing nothing. There are split-brain patients whose cerebral hemispheres, disconnected by surgery, can display two streams of behavior and apparently two separate centers of consciousness under certain tasks. There are patients in vegetative or minimally conscious states who exhibit wakefulness without reports of awareness, and locked-in patients who are fully conscious but utterly unable to move or speak. These phenomena point to the fact that consciousness is not identical to wakefulness, not identical to global behavioral competence, and not identical to any single brain area. Instead, it depends on a configuration of processes, integration, accessibility, reportability, whose interplay is subtle and delicate. When neuroscientists look for the physical substrate of consciousness, they identify patterns and systems more than single neurons. The cerebral cortex, with its dense recurrent connectivity, plays a central role in many theories because of its capacity for sustained, flexible integration. The thalamus, with its widespread projections, is implicated in the coordination of cortical activity. Brainstem arousal systems set the global conditions for wakefulness. Yet the mere localization of dynamics to certain regions cannot be the full story. The same neurons can participate in conscious and unconscious processing depending on how they are connected and the temporal patterns they form. Thus, consciousness begins to look like a process rather than a static property, a continuing, self-sustaining dance of information among subsystems, where the choreography matters as much as the dancers. Philosophy has been both a companion and a skeptic on this path. Materialists insist that mental states are brain states. They aim to show that once we understand the brain's causal organization, the appearance of subjective experience will be no more mysterious than life arising from chemistry. Dualists, in contrast, hold that subjective experience is of a different category and that physical accounts cannot exhaust it. Some dualists posit non-physical properties or realms. Between these poles there are intermediate views. Functionalism suggests that mental states are defined by their causal roles rather than by their material substrate. Panpsychism suggests, controversially to many, that proto-experimental properties are everywhere in nature, and that complex consciousness arises by special combinations of these properties. Pick any of these positions and you find a constellation of questions that refuse to let you rest. If you favor physicalism, you must explain how certain patterns of physical organization constitute feeling rather than mere function. If you lean panpsychist, you must explain what combination rules transform micro-experience into coherent subjectivity. If you embrace functionalism, you have to show how functional equivalence yields the same qualitative feel across different substrates. None of these moves is trivial, each has a cost in intuition or in the parsimony of explanation. Science is pragmatic, and it offers useful frameworks for progress. One influential idea is that consciousness is about the integration of information, not merely the storage of bits, but their unification into a structure that cannot be decomposed without loss. Another prominent model is the notion of a global workspace, a central broadcasting mechanism by which selected information becomes widely available to various specialized processors, memory, language, planning. When information enters the workspace, it becomes reportable and controls flexible behavior. The proposal appeals to the way conscious content seem to be globally accessible in our minds. A third trend reframes the brain as a prediction engine. Perception is not passive reception but active inference. The brain constantly generates models of the world and updates them against sensory evidence, and consciousness might be the phenomenology of certain successful predictions or of the precision weighting of prediction errors. Each of these models captures an aspect of experience. The integrated information account helps us understand unity and irreducibility. The global workspace explains reportability and flexibility. Predictive processing suggests why the brain represents the world the way it does and why perception feels like a continuous narrative. But none of them, alone, fully dissolves the feeling of a why hovering above their mechanistic descriptions. That is not a failure of science so much as a demand for conceptual humility. The explanatory gap between describing processes and accounting for subjective feel is real and persistent. Into this field of careful, often cautious inquiry have come more speculative ideas, especially those invoking quantum phenomena. The attraction is understandable. Quantum mechanics unsettles our intuitions about determinism, locality, and physical description. Some thinkers have proposed that certain quantum coherent processes in the brain might underwrite consciousness in ways classical explanations cannot. Yet the brain is warm and noisy. Quantum coherence, at least as it is understood in isolated, low-temperature physics experiments, tends to degrade rapidly in such environments. This has led most neuroscientists to treat quantum explanations with healthy skepticism. Still, it is worth keeping an open mind. Nature has surprised us before. The reasonable stance is to demand rigor and testability. If quantum processes play a role, we should be able to identify where and how, and to formulate predictive consequences that experiments could verify or falsify. As we approach this topic, it is vital to pay attention to the methods we use. Philosophers cultivate precision in conceptual analysis, neuroscientists refine experimental paradigms and technologies, theoreticians craft models that can be simulated and compared to data. But there is also a human dimension. The practice of reporting subjective experience is itself an art and a science. Introspection, when disciplined, can yield reliable data. First-person reports, organized and corroborated across subjects, can constrain theories. At the same time, self-report is noisy and shaped by language and culture. We cannot let the inevitable limitations of introspection blind us to its necessity. Scientific humility means synthesizing first-person and third-person data, not favoring one to the exclusion of the other. There is a poetic side to this study too. To think about consciousness is to think about the very ground of meaning, agency, and value. If consciousness is a continuous, unified stream, then the moral significance of beings, their capacity to suffer or to flourish, depends on the presence and character of that stream. This makes the science of consciousness not merely an abstract endeavor but an ethical enterprise. Understanding consciousness better could change how we treat non-human animals, how we care for patients with disorders of consciousness, and even how we design artificial systems that might someday exhibit forms of subjective processing. Evolution offers a narrative that both comforts and complicates. If consciousness confers some adaptive advantage, what is it? Perhaps it allows better integration of information across disparate modalities, or more flexible control over behavior in complex environments. Perhaps it facilitates social coordination by enabling beings to model not only the world but the inner states of others. Or perhaps consciousness is an epiphenomenon, a byproduct of complex information processing that introduces no extra causal powers beyond the physical processes that produce it. The epiphenomenon view is hard to accept emotionally because our felt experiences seem causally efficacious. I reach for my coffee because I am thirsty, but it remains a live philosophical possibility that forces us to be precise about causation and correlation. The first chapter of our inquiry must also confront the temptation to speak with finality. We are early in a long, multidisciplinary conversation. There are proposals and experiments, captivating metaphors, and stubborn counterexamples. Some ideas will be refined, others abandoned, some will merge and give rise to new frameworks. The careful reader should expect an unfolding, like a landscape revealed by a slow-moving sun. Certain features will sharpen while others recede into shadow. To make our future progress clear, I will take one promising stance here, not as dogma but as a working hypothesis. Consciousness is a biological process realized by particular patterns of organization and dynamics in complex neural systems. This process has the hallmark features of integration, global availability, and dynamic predictive engagement with the world. Subjective experience arises when these features coalesce into a temporally extended, self-referential loop that allows a system to take itself and its modeled environment as objects of processing. This definition aims to capture the archetypal qualities we have identified: unity, reportability, and temporal continuity, while remaining compatible with multiple mechanistic realizations. It is also intentionally pluralistic. It allows that different animals, and perhaps different artifacts, may instantiate different kinds and degrees of consciousness. Yet this working hypothesis leaves the hard problem alive. Even if we map the whole choreography of neural activity and produce a flawless simulation that reproduces every outward behavior and every reported experience, we would still feel the tug of the philosophical question. Why is there something it is like to be that system? Some will find this worry dissolvable by appeal to emergentism, others will treat it as a sign that our conceptual framework needs revision. Either way, the tension is productive. It pushes us to be more careful about what we mean by explanation, by reduction, and by emergence. At the level of practice, the study of consciousness is rapidly becoming an experimental discipline. New brain imaging techniques, richer behavioral paradigms, sophisticated computational models, and ethical frameworks for research are converging to make the questions tractable in ways they were not 50 years ago. But scientific progress does not guarantee conceptual clarity. True progress will come when empirical discoveries and conceptual insight reinforce one another, when a model not only predicts neural activity patterns but also offers a principled account of why those patterns correspond to particular qualitative states. As this book begins, imagine we are walking into a cathedral of knowledge that is still under construction. Some stained glass windows are already in place: evolutionary arguments, neural correlates, psychological experiments. Some scaffolding is visible: computational models, debates about integration and access. There are dark corridors we have yet to illuminate, the exact causal route from physical pattern to felt experience, the combinatorial rules that might govern how simpler experimental elements combine, the ethical consequences of creating or modulating consciousness. In the chapters ahead we will examine each of these spaces with care and skepticism, moving between the sciences and the humanities, between rigorous experiment and careful thought. I invite you, as reader and fellow traveler, to hold two attitudes at once: wonder and discipline. Wonder will keep us attuned to the rich phenomena of inner life, discipline will keep us honest about the limits of current knowledge and the need for testable claims. Consciousness resists being reduced to a slogan or folded into a single explanatory framework. It invites ongoing dialogue across fields and across styles of thought. This book will not claim to end the conversation, it aims to deepen it, to bring together biological detail, philosophical clarity, and, where warranted, cautious consideration of more speculative ideas. Before we step deeper, let's acknowledge one final truth that will guide us: the only way to study consciousness without betraying it is to move back and forth between perspectives. We must listen to the voice that reports what it is like and to the instruments that measure correlates. We must respect both the immediacy of lived experience and the rigor of third-person methods. Only by weaving these threads together can we hope to approach an account of consciousness that is at once explanatory, respectful of phenomenology, and empirically grounded. Chapter 2. If the first chapter asked us to stand back and look at consciousness as a question, a luminous knot where philosophy and science meet, then here, in the second chapter, we step closer and let our hands feel the texture of the thing. We move from metaphors to material, from the idea of an inner theatre to the cellular and circuit actors that, together, compose the living stage. This is not a recipe that reduces feeling to wiring diagrams, it is an attempt to trace how, in flesh and electrochemistry, the conditions for subjective life are woven. At the most intimate scale, the story begins with cells that have the unusual property of excitability. Neurons are not passive bricks, they are tiny machines built to register differences and to broadcast change. Each neuron maintains a voltage difference across its membrane, a delicate balancing act of ions pushed and pulled by channels and pumps. When this balance tips in the right way, the neuron fires an action potential, a stereotyped pulse that races down the axon, carrying the news of that tipping to other cells. That pulse is not information in a vacuum, it is a modulatory event whose significance depends on where it arrives, when it arrives, and what the receiving circuitry happens to be doing at that moment. Synapses, the junctions where neurons meet, convert these electrical pulses into chemical messages, neurotransmitters that bind receptors, open channels, and sculpt the electrical life of the next cell. In this cascade of charge and binding we can already see the basic grammar of neural signaling, timing, context, and pattern. But consciousness does not arise from single neurons acting alone, it is a property of ensembles, of populations whose interactions are patterned over space and time. The dendrites that stud a neuron surface are not mere antennae, they are computational compartments, actively shaping how inputs combine. Dendritic spikes, backpropagating action potentials, and nonlinear summation mean that single neurons can perform complex, context-sensitive operations. When many neurons with such properties are linked through recurrent connections, loops that feed activity forward and then back again, the system acquires the capacity for sustained reverberation, for holding patterns in a way that outlasts individual spikes. This recurrent circuitry is the neural equivalent of memory on a moment-to-moment scale. Patterns can be sustained, compared, and transformed. Here we meet an essential motif: integration through recurrence. Sensory inputs, arriving through specialized pathways, are rapidly transformed into distributed patterns across cortex. In early sensory areas the representation is faithful to the physical stimulus, in higher areas these representations become more abstract and relational. The richer the recurrent connectivity among regions, the more they talk back and forth, the greater the system's capacity to unify disparate features into a coherent content. This unity is a prerequisite for the sense that there is something it is like to have an experience, color tied to shape, sound tied to movement, memory tied to present perception. When the system integrates, the fragments bind into a scene. But integration alone is not enough. Neuroscience shows that the brain operates across many temporal and spatial scales, and that different modes of coordination provide different functional benefits. Oscillatory activity, rhythmic fluctuations of population-level excitability, organizes when neurons are most likely to communicate and when they are not. Slow rhythms set broad windows of coordination, faster rhythms allow fine-grained temporal binding. Cross-frequency interactions, the nesting of fast bursts within slower cycles, create a multiplex scaffolding for information exchange. One can imagine these rhythms as a conductor's baton, coordinating sections of the orchestra so that sounds that belong together are heard together, and signals that should not interfere are kept apart. When these rhythms are well coordinated across cortical regions, information can be routed flexibly and selectively. When they fall out of step, communication falters and experience can fragment. Another central component in the biological story is modulation. The brain is not a clockwork that runs the same way all the time, it is steeped in neuromodulatory influences that tune the rules of engagement. Neurochemicals such as dopamine, acetylcholine, norepinephrine, and serotonin do not simply encode sensory content, they regulate learning rates, signal salience, and alter the gain with which networks respond to inputs. When neuromodulatory systems shift, the same stimulus can be ignored, noticed, or assigned urgent meaning. They provide the brain with a metacontrol, a way of biasing which circuits will be privileged for integration and which will be suppressed. In the theater of consciousness, neuromodulators help decide which scenes are spotlighted and which recede into the wings. A recurring empirical observation is that conscious processing seems to require both local specialization and global communication. Certain brain regions are specialized for processing particular kinds of content, faces, motion, language, but the hallmark of what we experience is not that these regions light up in isolation. Instead, conscious contents are typically accompanied by widespread co-activation. Sensor-specific nodes become embedded in a broader web that includes memory, language, valuation, and motor planning circuits. This wide dissemination makes information available for flexible use, to guide decisions, to be reported, to be stored. Some theories describe this phenomenon as a global workspace, a space of broadcast that allows particular content to be accessed by many subsystems. Whether we call it a workspace, an integrative core, or a dynamic coalition of networks, the key idea is that consciousness involves information that is both richly structured and widely available. Yet the biological canvas is not merely cortical. Subcortical structures, the thalamus with its hubs and relay modes, the brainstem with its ascending arousal systems, the basal ganglia with their gating functions, set the conditions for the cortex to be expressive. The thalamus is often pictured as a switchboard, modulating which cortical circuits are permitted to resonate. Brainstem nuclei, by regulating wakefulness and the tone of neuromodulatory systems, establish the background upon which conscious states can unfold. Damage to these systems can abolish the conditions for consciousness, not because they directly host the content, but because they impoverish the dynamic context that makes content possible. The biological lesson is that consciousness is a system property, it depends on the interplay of many parts, some of which set the stage while others perform the scene. Glial cells, long thought to be mere support staff, also play roles that complicate the picture. Astrocytes regulate the chemical milieu, modulate synaptic strength, and participate in metabolic coupling between neurons and blood flow. Their slow calcium dynamics and diffuse signaling hint at modes of coordination that are different from the rapid spike code of neurons. Microglia surveil and sculpt synaptic landscapes. Oligodendrocytes influence the speed of conduction by myelination patterns. Though the precise contributions of glia to consciousness remain under active investigation, their presence reminds us that finding the neural basis of experience requires attention to the whole biological ensemble, not just to action potentials. Learning and plasticity are another biological thread deeply entangled with consciousness. Synaptic strengths adjust through activity-dependent rules, repeated co-activation tends to strengthen connections, while disuse weakens them. These changes accumulate over seconds, minutes, days, and years, altering the networks that will be available for immediate integration. Memory, both short-term and long-term, thus shapes the palette of experiences that a system can assemble. A conscious scene is never purely current sensation, it is threaded with expectations, shaped by past learning, and laden with the value structures that prior experience has carved into the circuitry. This brings us to a particularly fruitful way of thinking about neural function, the brain as a prediction engine. Rather than merely passively registering inputs, the system constantly generates models of the world and tests them against incoming data. Top-down signals convey expectations, bottom-up signals convey mismatches. Consciousness, from this vantage, might be associated with particular configurations of prediction and error, especially with the assignment of precision, the confidence the system has in particular signals, that determines which errors lead to updating and which are treated as noise. When prediction and sensory evidence are tightly integrated, experience feels stable and continuous. When prediction errors dominate, experience can fracture into surprise and confusion. Time is a final and vital ingredient. Neural processes unfold over a spectrum of timescales, from millisecond spikes to slow modulatory trends to long-term synaptic remodeling. Conscious experience likewise has temporal texture. A glance can become a sustained perception, a fleeting impression can blossom into a narrative. There is evidence that certain durations of recurrent exchange, on the order of hundreds of milliseconds, are particularly relevant to forming stable, reportable contents. But consciousness is not a single clocked event, it is a flow, a dynamic process in which past, present, and expectation entwine. All these biological pieces give us an increasingly vivid picture of how a living brain could assemble the conditions for subjective life. Integration, recurrence, oscillatory coordination, neuromodulation, functional dissemination, and plasticity are the recurring motifs. Yet at every turn we are reminded of the gap between description and feeling. We can map the circuits that sustain a visual percept, follow the firing patterns that correlate with the recognition of a face, and show how lesions modify these processes, and still the question remains why these patterns are accompanied by the qualitative feel of seeing. The biological account narrows the space of plausible explanations. It tells us what structures and dynamics must be in place, and what changes abolish or alter experience. But it does not, on its own, dissolve the philosophical puzzle. This is not a failure of biology, it is its strength and its restraint. By articulating the necessary conditions for consciousness, and by demonstrating, through perturbation and observation, that certain configurations reliably produce or abolish experience, neuroscience provides a scaffold for deeper theorizing. It transforms woolly intuitions into concrete hypotheses. If recurrent thalamocortical loops are disrupted, conscious content diminishes. If neuromodulatory tone is altered, the salience and texture of experience changes. If the capacity for integration is lost, unity fractures. These are testable claims, and their systematic investigation advances our understanding in ways that pure speculation cannot. There remain, however, provocative open questions that the biological approach must confront. What are the minimal architectures sufficient for subjective life? Can simple nervous systems, those of insects or cephalopods, support forms of experience that are different in degree or kind from human consciousness? How do the temporal hierarchies of the brain generate the sense of a unified self that persists through time? What is the role of the body, its hormones, viscera, and peripheral nervous system in constituting the felt aspect of being? And perhaps most pressing, to what extent does the biological substrate matter? Could artificial systems built of silicon and code, if they replicated the functional dynamics of integration and recurrence, support experiences like ours? When we press on these questions, the biology keeps us honest. It cautions against naive reductionism. Consciousness is more than a single molecule or a single circuit, while also warning against magical thinking. There is nothing in known biology that necessitates an immaterial ghost. The most fruitful path, it seems, is one of careful humility, to map, perturb, and model, and to let the data guide the conceptual revisions. From this patient labor we should expect both incremental clarification and occasional surprises. The latter, unexpected roles for glia, novel synchronization phenomena, new classes of neuromodulatory interactions, are likely. Science, after all, is not merely a confirmation of prior belief, it is a process that reshapes the questions we thought we were asking. As we close this chapter, we should carry away two practical convictions. First, consciousness is best understood as a process instantiated by a multi-scale biological ensemble. It requires the microphysics of excitability, the mesoscale of recurrent networks and oscillations, and the macroscale of distributed broadcast and modulatory tone. Second, while biology can specify the architectures that make consciousness possible and can track how changes to those architectures change experience, it also leaves open a deep explanatory tension, the sense that descriptive maps do not automatically convert into accounts of subjective feel. This tension will drive our next moves, to examine the computational frameworks that try to bridge mechanism and phenomenology, to interrogate the theories that measure integration and information, and to test hypotheses that link dynamic patterns to the qualities of experience. For now, remember that the living brain is not a static machine but a history-making, self-tuning organ. It does not merely host experience, it shapes and is shaped by it. In that reciprocity, between structure and process, between biology and momentary feeling, lies the most promising trace we have of how consciousness can arise. Chapter 3. If the last chapter laid out the living machinery, neurons, oscillations, modulators, thalamic gates and glial accomplices, this chapter asks a different question. Once the machinery exists, what is the logic by which it becomes a mind? Biology gives us parts and propensities, computation and theory give us the grammar that organizes those parts into something that looks, from the inside, like a continuous, meaningful life. To think about this grammar is to ask how processes of representation, selection, and integration can be assembled into a system that not only reacts but knows that it is reacting, a system that does more than compute, a system that lives within its computations. From early cybernetic dreams to contemporary cognitive neuroscience, thinkers have treated the brain as an information processing device. But that phrase, information processing, is porous. It can mean many things: thermodynamic exchange, statistical description, algorithmic transformation, or the semantic handling of meaningful content. Each of these senses pushes us into different territories. The challenge is to discover which formalization best captures the phenomena we care about, the unity of perception, the stream of experience, the sense of self, the feeling that there is something it is like to be a system at all. Over the past century, several converging, sometimes competing, computational narratives have claimed at least partial success. Each tells a story about what consciousness does and how it might be instantiated. One dominant story casts consciousness as a stage of global availability. On this view, the brain is an ensemble of specialized processors, modules for vision, audition, language, motor planning, valuation, each with local expertise. Consciousness arises when some information is selected and broadcast widely, so that many of these processors can access and act upon it. The metaphor is of a spotlight on a dark stage, or of a central theater where selected contents are made public to the system's subparts. This global availability accounts naturally for the flexibility of conscious behavior. When a percept enters the workspace, it can be reported, stored in working memory, tied to planning, and chained into complex sequences of action. It also explains why conscious contents are often correlated with sustained, widespread neural activation rather than with the transient sparks of localized processing. Yet this model leaves open questions. What precisely is being broadcast? How does selection occur? And crucially, why does broadcast feel like anything at all? To translate the global availability insight into an account of subjective feel, theorists refine the story. Not only must information be globally available, it must also be integrated in a way that preserves structure and context, and it must be linked to systems that model the organism itself. Thus the global workspace becomes richer, a dynamic hub where content is both widely usable and reflexively modeled. Another influential line reframes the problem in terms of integration of information. Here the key idea is that consciousness is characterized by unity and irreducibility. A conscious state is not a mere sum of independent parts but a highly integrated pattern whose information cannot be decomposed without loss. Formalizing this intuition, some theorists propose quantifying the degree of integration that a system's causal structure supports. The mathematics attempts to capture precisely how much more the whole system says about its past and future than its parts do independently. If a system's causal links weave a tightly interdependent fabric, it scores high on integration. If it decomposes into relatively autonomous modules, it scores low. This gives us, in principle, a measure that can compare architectures and predict the presence or absence of consciousness. It aligns with the felt unity of experience and with the observation that certain lesions that fragment cortical integration also fragment conscious content. But the integrated information approach too encounters hard decisions. Which elements of physical causation matter? How should we aggregate micro-level interactions into macro-level experiences? Does high integration guarantee phenomenality, or merely signal potent information processing? And can a mathematical scalar ever fully map onto qualitative texture the difference between seeing red and tasting coffee? The attempt to formalize the ineffable is admirable, and it brings rigor to the debate, but it also exposes a deeper tension. Computation speaks in functions and mappings, whereas phenomenology speaks in what it is like. One can pursue the mapping between these vocabularies and hope for convergence. One can also accept that a residual conceptual leap will remain. A third thread pursues the Bayesian logic of the brain. It is not a passive receptor but an active hypothesis machine. Perception here becomes a controlled hallucination, a running set of predictions about sensory input that are continually corrected by errors. Consciousness, on this picture, may be the experienced content of predictive models weighted by their precision. The brain infers the causes of its sensations and generates the best explanations given prior knowledge and current evidence. Experience is thus the felt narrative of those inferences, the brain's most confident hypothesis about the state of the world and of itself. This formulation elegantly links perception with action. Models guide movement, movement tests models, and discrepancy drives learning. It explains illusions and delusions as cases where priors trump evidence, and it offers a path toward understanding how expectation colors experience. Predictive models have a persuasive psychological plausibility. They account for the continuity of experience and for the way context shapes perception. They also suggest why conscious contents often have a narrative, anticipatory quality. Yet the predictive framework must still specify when and how a prediction becomes phenomenal. Many inference processes are unconscious. The theory needs principled constraints to distinguish mere computation from felt modelhood. Perhaps it is the assignment of precision, a metacognitive weighting of signals, that demarcates conscious hypotheses from the submerged churn of prediction. Or perhaps conscious content arises when models are embedded in a particular global access architecture that allows their outputs to be flexibly used. Related to the Bayesian story are theories that emphasize higher-order representation. These propose that consciousness involves not just a representation of the world but a representation of representation, a thought about a perception. When the system forms a higher-order state that tracks a lower-order sensory state, that tracking might constitute awareness. This has an intuitive appeal. To be conscious of seeing red is, in a loose sense, to have a mental state that is about the seeing itself. Higher-order views capture why metacognition, reportability, and reflective thought are often entangled with consciousness. They also provide a natural account of certain pathologies. Deficits in higher-order representation might explain blind sight, where visual processing occurs without accompanying awareness. Yet critics point out that higher-order views risk making consciousness depend on a cognitive luxury, a reflective stance, that seems absent in many animals and even in infants. If awareness always requires a thought about the thought, are creatures without sophisticated metacognition forever excluded from the realm of experience? Proponents respond by broadening what counts as higher order. It need not be a language-laden judgment, but could be any monitoring process that instantiates a representation of the system's own states. In this softened form, higher-order accounts mesh with global and integrative frameworks. Monitoring, broadcasting, and integration may be different facets of a single architecture. The computational debate intersects with another axis of inquiry, the distinction between access and phenomenology. Some theorists emphasize access, the availability of information for report and control, as the hallmark of consciousness. Others insist that there is always more to experience than what can be accessed and reported. There is a private, ineffable surplus that resists functional description. This philosophical tension is not mere hair-splitting, it shapes experimental design. If we equate consciousness with reportable access, then pragmatic markers like verbal report and behavioral choice are central. But if phenomenology can outstrip access, we must develop subtler assays, no-report paradigms, physiological markers, and careful phenomenological elicitation. The computationalist's toolbox also reaches toward questions of substrate and implementation. Functionalists argue that what matters is not the material, silicon, carbon, wet tissue, but the pattern and causal organization. If the same functional roles are realized, the argument goes, equivalent conscious states could obtain in radically different substrates. This is the theoretical foundation for a science of artificial consciousness: replicate the right architecture and you replicate experience. The opposing intuition, however, is that substrate may matter. Biological tissues could have intrinsic properties relevant to phenomenality, or microphysical implementation could shape qualia in ways mere function cannot capture. The debate has practical stakes. It bears on whether advanced AI systems might become conscious and on how we should treat them morally. Throughout these computational conversations, philosophy stages its classic thought experiments. Consider the hypothetical being who behaves and reports as we do but has no inner life, the philosophical zombie. Does the coherence of computational theory make such zombies conceivable, or does it force us to accept that behavior and reportability necessarily imply phenomenality? Consider Mary, the color scientist who knows every physical fact about color vision but experiences a new dimension on first seeing red. These thought experiments are not idle puzzles, they pressure test the explanatory completeness of computational accounts. If someone can know all the functional facts and yet miss the qualitative, then perhaps computation leaves something out. If instead a robust theory of representational and integrative dynamics can reconstruct the missing facts, then the intuition behind Mary may be dissolved. In practice, these debates are not purely abstract. They yield different empirical programs. A theory that privileges global broadcast predicts that manipulations reducing dissemination should reduce reportable awareness while leaving local processing intact. A theory centered on integration predicts that measures of irreducible causal interdependence will correlate with subjective states across species and conditions. Predictive models suggest we should see brain activity consistent with hierarchical inference during conscious perception, and that altering the precision of prediction errors should alter phenomenology. Higher-order accounts point to the importance of metacognitive signals and prefrontal monitoring. Converging experiments, manipulations, recordings, perturbations can thus adjudicate among these proposals, or perhaps show that they are complementary descriptions of different aspects of the same underlying phenomenon. An honest appraisal recognizes that these computational models are not mutually exclusive in all respects. They often highlight different levels of description. One might see integrated information as capturing the degree to which a system's causal structure supports unified experience, while a global workspace describes a particular computational implementation of broadcast and flexible use. Predictive processing might articulate the content and temporal dynamics of those broadcasts, and higher-order theories might account for the reflexive awareness that indexes certain contents for report. The synergy of these narratives, each illuminating facets of an intricate diamond, may be the most productive stance. The challenge is to weave them into a coherent multilevel account that links formal measures to mechanisms to phenomenology. We must also remain attentive to the limits of computation as an explanatory idiom. Computation gives us means to describe how systems transform inputs into outputs and how they represent states. It does not, by itself, answer whether and why those transformations are accompanied by felt quality. For some, this indicates a conceptual gap that demands new metaphysical commitments. For others, it is a methodological pause signaling that our language must be sharpened so that the supposed gap collapses under careful analysis. Either way, computation has already proven indispensable. It provides testable predictions, clarifies concepts, and constrains speculation. Any mature account of consciousness will be computationally informed even if it remains philosophically open. Finally, the computational perspective forces us to re-examine our own intuitions about agency and value. If consciousness is a kind of structured, integrated information that enables flexible control, anticipation, and self-modeling, then the capacities we value, empathy, creativity, moral judgment, may be built upon the same computational scaffolds that create our felt world. This lifts the study of consciousness from a purely academic exercise into the heart of ethics and social life. The ways we design systems, care for other organisms, and shape institutions will be informed by the computational architectures we endorse. As the chapter closes, carry forward a practical humility and a methodological eagerness. Computation does not offer a single, tidy answer to the mystery of experience, but it offers a rich landscape of hypotheses that can be tested, refined, and sometimes discarded. The next steps are empirical and conceptual, to map the signatures predicted by each theory onto the living brain, to develop measures that bridge causal structure and phenomenology, and to cultivate a language that can translate between mathematics and the felt texture of life. The journey is as philosophical as it is technical. The tools are algebra and introspection, simulations, and patient observation. In pursuing them, we inch closer to an explanation that, even if it does not finally dissolve the hard problem for every mind, will at least illuminate how brains, and perhaps other systems, weave the raw materials of sensation and history into the luminous tapestry we call conscious experience. Chapter 4. There is a quiet stubbornness to the lived moment that resists being fully captured by any map or model. You can point to neurons, sketch circuits, write down equations that describe how activity propagates, and still, when you close your eyes and dwell for a beat on the redness of red or the ache behind a memory, a directness remains that seems to elude translation. That directness is phenomenology, the structure and texture of experience as it presents itself from the inside. If earlier chapters walked us through hardware and computational grammar, this chapter moves inward to the phenomena themselves, to what it is like to be a perceiver, a feeler, a self, and to the stubborn puzzles those phenomena create for any explanatory project. Start with the raw sense of stimulus quality. When light of a certain wavelength strikes the retina, physiology can tell us which cones are activated, which retinal ganglion cells fire, which cortical columns resonate. But the experience, the redness, the sourness, the particular timbre of a violin, is not a mere list of activations. It has a qualitative feel, a phenomenal character. Philosophers have long labeled these qualities qualia, not as a theoretical pronouncement but as a name for the part of experience that seems ineliminably first-personal. Qualia are the immediate, ineffable tone of sensation, and they raise a stubborn question: how do patterns of objective firing acquire the private hue that we call what it is like? Closely allied to qualia is unity. At any moment our senses deliver a cacophony, color gradients, contours, the creak of a chair, the feel of breath on skin, a remembered joke tucked behind a sorrow. Yet we do not experience these as a mishmash but as a coherent scene inhabiting a single perspective. This is the binding problem in its experimental guise: how do disparate sensory streams become woven into a unitary field? Empirically we see candidate mechanisms, synchronous oscillations, recurrent loops, cross-modal convergence, but phenomenology insists on more than temporal correlation. There is a felt singularity to the scene, the world appears from somewhere, and that somewhere is the locus of consciousness. Any adequate account must explain not only how signals are combined but why they are combined into a single point of view. Attention is one of the great sculptors of phenomenology. It acts less like a spotlight that illuminates and more like a sculptor's hand that brings some features into relief while letting others recede. What we attend to acquires vividness, stability, and narrative traction. What we do not attend to remains background, sometimes entirely absent from report despite being processed. Attention is selective in space and time, but it is also selective in depth. A peripheral stimulus may be detected at a sensory level without entering the intimate space of felt awareness. This selectivity is instructive. It suggests that phenomenology is not a global byproduct of all processing but an emergent property of particular selection and amplification mechanisms that grant content privileged access to integrative resources. Time, the lived present, is its own mystery. Our subjective experience is not a frozen snapshot but a flowing stream. Philosophers and psychologists speak of the specious present, an extended now, perhaps a few hundred milliseconds to a few seconds long, in which events are experienced as co-present and ordered. Within that window, the brain stitches together sequences, infers causation, and forms narratives. Temporal binding underwrites not only perception but the sense of agency. We feel that our intentions precede and cause our actions. Yet the neural implementations of temporal continuity are complex, distributed across oscillatory regimes, recurrent loops, and memory buffers. Phenomenology insists that time in experience is more than ticking clocks, it is the medium of meaning-making itself. Closely tied to temporality is the sense of self. Phenomenology does not present a single, solid I'm as a datum, rather it offers layered structures. At the most basic level there is the minimal self, the pre-reflective sense of being a subject situated here and now, with perceptions and sensations that are mine. Laid upon this is the narrative self, a constructed identity that spans minutes, years, and stories, woven from memory, language, and social recognition. The minimal self is immediate and bodily, the narrative self is temporal and social. Both are phenomenologically real, but they can dissociate. In moments of depersonalization, the minimal self feels estranged. In certain meditative states, the narrative self shrivels while the minimal sense of being remains. Any complete theory must account for how the brain constructs both the thread that ties experience into a present point of view and the longer arc that stitches those points into identity. Agency and authorship sit at the crux of phenomenology's ethical and existential stakes. We do not merely perceive, we act, choose, regret, and plan. The phenomenology of agency involves a sense that actions are caused by intentions emanating from an integrated self. Yet empirical studies show that the timing and causal structure of intention and action are complicated. Preparatory brain signals can precede conscious decisions, and post hoc rationalizations can reshape recollections of why we acted. The felt sense of agency is thus at least partly constructed, a narrative assembled from predictive models, sensory feedback, and higher-order monitoring. This construction does not demean agency, it places it into a naturalistic framework and forces us to ask what makes that felt authorship reliable and morally relevant. Emotion and affect color phenomenology in profound ways. They are not epiphenomena attached to cool perception, they are the dye that saturates the fabric of experience. Fear narrows attention, heightens certain sensory channels, and floods the body with preparatory signals. Joy opens the temporal window to novelty and social connection. Interoception, the brain's representation of the body's internal milieu, is central here. The feel of a racing heart, the knot in the gut, the warmth of contentment, these bodily states are not mere reports but constitutive aspects of affective experience. From this perspective, emotions are embodied predictions that layer meaning onto sensation and reshape the dynamics of attention and memory. Understanding phenomenology therefore requires we understand how bodily signals are represented, predicted, and integrated with exteroceptive content. Sociality is another formative context for phenomenology. Much of what we experience is framed by the presence, imagined or real, of others. We feel shame, pride, empathy, and affiliation, we track intentions in others, infer minds, and build shared realities through language. Language itself restructures phenomenology. Having words for a feeling can make it more discriminable, persistent, and socially communicable. Cultural practices, rituals, art, narrative forms, scaffold modes of attention and ways of interpretive weaving. The lived world is not merely a private theatre but a theatre that is rehearsed, judged, and co-created by other minds. The social scaffolding of phenomenology invites us to treat subjective states as not only neural events but as relational phenomena embedded in a network of practices and expectations. Phenomenology is not uniform across development or species. Infants experience the world in ways that are not merely smaller-scale versions of adult experience. Their temporal windows, attentional capacities, and social scaffolds are qualitatively different, and so are the textures of their feelings. Comparative studies suggest that many animals have forms of subjective life attuned to their ecological needs. A cephalopod's felt world, a bat's sonic landscape, a primate's social tapestry could be radically different in content and organization without being less genuine. This plurality of forms presses an important philosophical point: phenomenology is multiply realizable. If so, the aim is not to map a one-size-fits-all pattern but to identify the organizational principles that allow a system, biological or artificial, to have perspectives of any kind. Pathologies of experience are, paradoxically, among phenomenology's greatest teachers. Conditions such as anosognosia, in which patients are unaware of their deficits, or certain forms of schizophrenia, where the boundaries of self and other blur, reveal how fragile the constructions of awareness and authorship can be. Split brain cases show that unitary reportability can fracture into multiple quasi-independent centers of perspective. Depersonalization strips color from the narrative self. Blind sight separates goal-directed visuomotor behavior from the felt seeing. These dissociations constitute empirical counterexamples to naive identifications of behavior with phenomenology. They show that different components, integration, reportability, metacognition, interoception, can vary independently, and that phenomenology depends on their particular conjunctions. Faced with this rich terrain, how should science approach phenomenology? One approach is pragmatic and pluralistic: take first-person reports seriously but treat them as data to be correlated with third-person measures. Another is methodological rigor, refine introspective techniques, use no-report paradigms that infer phenomenal content from behavior and physiology, and develop rigorous phenomenological interviews that place minimal linguistic framing between experience and report. A promising middle path is neurophenomenology, using disciplined subjective reports to guide and constrain models, and using those models to suggest new introspective distinctions. This two-way traffic recognizes that phenomenology is both the explanandum and a source of hypotheses about underlying mechanisms. Bridging phenomenology to mechanism requires careful translation. Words like red or pain are porous, referring not only to proximal sensory attributes but to histories, contexts, and cultural schemata. Theoretical frameworks attempt to make the bridge. Predictive processing grounds phenomenology in hierarchies of inference. What it feels like is the system's best model of the causes of its sensations. Higher-order theories frame awareness in terms of representations of representations. Integrated information theories attempt to quantify the irreducible structure of experience. Each has something to contribute. Prediction accounts explain temporal continuity and expectation-laden perception, higher-order accounts handle metacognition and reportability, integration-focused theories highlight unity and irreducibility. Yet none, so far, reduces the qualitative to the formal without remainder. That residue is not evidence of failure but of conceptual depth. Phenomenology resists being flattened, and any successful account must be comfortable with multiple levels of description. Finally, phenomenology carries ethical implications that are immediate and unavoidable. The fact that experience is the seat of suffering and joy means that questions about who or what has experienced matter morally. If phenomenology is multiply realizable and not human exceptionalist, then our moral circle has to be rethought in light of the capacities and forms of subjective life in animals and machines. If the narrative self is a construction, how do we weigh the claims of beings whose constructions differ from ours? These questions are not speculative footnotes but practical imperatives. They compel us to align scientific curiosity with ethical responsibility. In the quiet that follows reflection, phenomenology leaves us with a paradoxical feeling, intimacy and opacity. We know our experiences as no one else can, and yet that very intimacy resists outward translation. This is not a call to mysticism but to methodological humility and imaginative rigor. Phenomenology demands that we listen carefully to the voice inside while we train our instruments outside. It asks us to develop languages precise enough to capture subtle distinctions, models that can accommodate layered descriptions, and experimental designs that respect first-person realities without being fooled by them. The task is both empirical and interpretive, to chart not only the mechanical paths of signals but the meanings those signals acquire when woven into the tapestry of a life. When you next notice the texture of a breath or the sudden warmth of recognition, you are at once participant and data point. Phenomenology is not a static catalogue but an ever-renewing practice. Attending to the inside of experience refines our questions, sharpens our models, and keeps us honest about what it truly means to explain consciousness. In the chapters ahead we will take these lessons with us as we examine specific theories and experiments that seek to translate the intimate into the intersubjective and the formal, always remembering that the map is valuable precisely because it is not the territory it seeks to describe. Chapter 5. If the earlier chapters have been a movement from scaffolding to grammar to felt life, this chapter turns its gaze to origins, to how consciousness might have come to be, not as a single miraculous birth but as a slow, knotted process of development and selection. To ask how consciousness arises is also to ask how it develops in an individual and how it could have been favored or shaped by evolution. Development and evolution are twin lenses. One shows the recapitulation of capacities in time within a single organism, the other shows their gradual accrual across deep time. Thinking with both gives us a richer account of what kinds of systems can feel and why. Imagine, for a moment, the earliest nervous systems, arrays of excitable cells lining a tube, coordinating contraction, allowing a simple animal to orient toward food and away from harm. These beginnings are humble. There is no grand theatre, only sensoromotor loops that transform stimulus into movement. Yet even these primitive loops instantiate a crucial capacity. The system state is about something in the world insofar as it regulates action in service of maintaining a living integrity. From the vantage of function, this is the seed of valence, primitive goodness and badness, because some states promote survival and others do not. If feeling, at its rawest, is a way for a system to represent what matters to it, then even a simple organism's metabolism-coupled responses instantiate protoforms of valenced experience. As nervous systems became more elaborate, new architectural motifs emerged: centralized ganglia, recurrent connections, sensory maps, and later, layered processing hierarchies. Each structural innovation opened new computational possibilities: the ability to sustain representations over time, to compare predictions against incoming signals, to integrate disparate sensory channels. With these capacities came new opportunities for the organism to benefit from internally coherent representations, better navigation, more flexible foraging, improved predator avoidance. Natural selection, by tuning these capacities, could have favored systems that not only reacted but anticipated, that formed models of the environment and of the organism's relations to it. What begins as an engineering advantage gradually acquires phenomenological implications. The predictive models that guide behavior become the candidates for what it is like to be that organism. This gradualist view admits degrees and kinds. Consciousness need not be an all-or-nothing property that suddenly appears at some taxonomic boundary; rather, it is plausibly a graded phenomenon. At the bottom are systems with minimal sentience, the capacity to register valence, to differentiate internal from external signals, to guide simple homeostatic responses. At higher levels are organisms capable of richer integration, binding modalities into unified scenes, maintaining working memory across hundreds of milliseconds, engaging in flexible, context-sensitive planning. Social organisms developed still further layers: the ability to infer others' intentions, to represent social hierarchies, and to participate in shared symbolic frameworks. With each evolutionary advance, the phenomenological repertoire broadens, not simply in complexity but in kind. A bat's inner world, organized around echolocation, will feel categorically different from a primate's visually structured life. Yet both could be forms of genuine subjective perspective. Developmental processes recapitulate this layered emergence within the lifespan of an individual. A human embryo's nervous system scaffolds itself through genetic programs interacting with activity-dependent plasticity. Early sensations are rudimentary and tied to bodily regulation. Later, as cortical circuits elaborate and recurrent loops stabilize, sensory representations become more differentiated and integrated. Critical periods of plasticity shape the sensory maps that will underwrite later perceptual richness. Language and social interaction overlay these neural architectures with symbolic scaffolding that transforms the raw field of immediate perception into narrative-rich, temporally extended selfhood. Thus, development is not mere growth of capacity, it is the cultural and embodied shaping of phenomenology itself. This interplay of biology and environment suggests a central insight: consciousness is not only constructed by the brain but sculpted by the history of interactions between organism and world. The body matters. Interoceptive signals, the ongoing registration of visceral states, are integrated with exteroceptive streams to produce the felt texture of emotion and bodily presence. Motor capacities shape perception: what an organism can do with its body changes what it needs to represent and how richly. The niche an organism occupies, forest canopy, ocean depths, social group, determines the selective pressures on representational systems. Consciousness, then, is an embodied, embedded product. The architecture of feeling is tuned to the life a creature leads. What evolutionary functions might consciousness plausibly serve? Theories converge on a few adaptive advantages. One is integration for flexible behavior. By unifying information across modalities and time, conscious systems can coordinate complex sequences and adapt to novel situations in ways purely reflexive systems cannot. Another is the enabling of counterfactual thinking and planning. A system that can model not only what is but what might be can choose actions that better satisfy long-term goals. A third is social cognition. Representing others' mental states is invaluable for cooperation, deception, and cultural transmission. Conscious access might make sophisticated modeling of others tractable. Finally, consciousness could facilitate learning by amplifying salient prediction errors and directing plasticity where it matters most. Each of these functions confer survival or reproductive advantages, making consciousness a plausible target of natural selection. But evolutionary narratives are slippery, and honest thinking resists simplistic adaptationism. Phenomenal consciousness could be a byproduct, an emergent epiphenomenon, of complex information processing architectures that were selected for other reasons. The difference matters conceptually. If consciousness is causally efficacious, it contributes to fitness directly. If it is an epiphenomenon, natural selection shaped the underlying mechanisms for their behavior-shaping capacities regardless of the accompanying feel. Empirically disentangling these alternatives is difficult. Functionally, however, the distinction often blurs. The systems that implement attention, working memory, and prediction, mechanisms that enhance behavior, are also those that correlate with consciousness. Whether the subjective feel is a driver or a passenger. Evolution sculpted the neural machinery that produces both. Comparative studies illuminate the plurality of minds. Octopuses and cephalopods show problem-solving and flexible behavior with a nervous system organized quite differently from vertebrates. Corvids and parrots rival primates in certain cognitive tasks despite different brain morphologies. Social insects coordinate complex collective behaviors through distributed decision-making mechanisms. These examples emphasize multiple architectures can yield powerful cognition, and they raise pressing questions: which architectures support subjective experience and to what degree? Is the kind of integration found in cephalopod ganglia sufficient for consciousness, or does it require vertebrate-like cortical dynamics? Is a distributed, colony-level decision-making process enhance a kind of collective consciousness? Reasonable answers require humility and an empirical program that correlates behavior, neural structure, and, where possible, report-like indicators of subjective states. From a developmental standpoint, language and culture transform raw consciousness into richly articulated selves. Words allow discretization and re-entrainment of experience, categories render differences salient, and narratives integrate episodic content across time. Cultural practices, rituals, art, moral systems, shape attentional habits and the salience of particular experiences. Thus, while the neural substrate provides capacities, culture amplifies and channels them into distinct human forms of phenomenality. This is why introspective descriptions and cross-cultural studies are essential for a complete picture. The texture of experience is not solely a matter of neurons but of stories told within societies. The possibility of multiple realizability has implications beyond biology. If consciousness depends principally on organizational patterns, certain degrees of integration, global availability, hierarchical predictive modeling, then artificial systems that instantiate these patterns might, in principle, have experiences of their own. But evolution's tinkering and development embedding cautious architecture alone is not enough. History and embodiment matter. A silicon agent devoid of a body, of interoception, of metabolic constraints, and of a life-or-death ecology may compute beautifully but lack the scaffold that gives rise to valenced, embodied phenomenology. Whether one can engineer the relevant scaffolding artificially is an open and ethically fraught question that touches on design choices, moral status, and the responsibilities of creators. The study of developmental disorders and of altered states further sharpens our hypotheses about what is required for conscious life. Cases where integration is disrupted tend to show fragmentation of experience, where interoception is impaired, affective coloring changes, where social cognitive machinery is atypical, narratives of self may diverge. Such dissociations argue for a multi-component account. Consciousness requires a conjunction of integrative processing, adequate levels of arousal and neuromodulation, mechanisms for global availability and metarepresentation, and a body that affords interoceptive grounding. When one or more components fail to cohere, the texture, unity, or authorship of experience can unravel in instructive ways. Evolutionary and developmental accounts also caution against anthropocentrism. It is tempting to measure other minds against human benchmarks, language, self-report, explicit theory of mind, but doing so risks occluding genuinely different forms of consciousness. A dolphin's deep acoustic life, a bee's valenced odor world, or an octopus's decentralized sensing might be phenomenally rich in ways alien to us. Ethical reasoning must therefore rest on capacities and architectures, not on superficial behavioral resemblance alone. Recognizing degrees and kinds of subjectivity widens rather than dilutes our moral imagination. At the level of philosophical implication, developmental and evolutionary perspectives push us toward pluralism. If consciousness evolves in layers, is embodied, and is realized in multiple architectures, then a monolithic metaphysical account may be implausible. Instead, we might accept a family of explanations, accounts that link particular forms of organization to particular kinds of experience. This pluralism does not dissolve the hard questions, the why of feel, but it reframes them in terms that are empirically tractable. What organizational changes shift phenomenology, and how do developmental histories shape the axes along which experience varies? As the chapter winds down, we should acknowledge how much remains to be discovered. The fossil record does not reveal minds, and neural tissue rarely fossilizes. Evolutionary inference must therefore be cautious and integrative, combining phylogenetics, comparative neuroanatomy, and behavioral ecology. Developmental trajectories vary across species and individuals. Longitudinal studies, refined behavioral assays, and careful phenomenological interviewing are needed to map the emergence of capacities. Experimental manipulations, reversible perturbations of integration, neuromodulation, or predictive hierarchies offer ways to test causal links between architecture and feeling. Each of these empirical moves must be coupled with philosophical clarity so that terms like conscious, sentient, and self retain operational content. Ultimately, the twin stories of development and evolution remind us that consciousness is neither a mystical endowment nor a brittle artifact. It is the product of histories, of genetic programs, of ecological niches, of cultural practices, of accidents and affordances. By tracing those histories, we do not merely tally facts, we deepen our understanding of what it takes for life to become a world for someone. That insight reframes many questions, not only how does consciousness arise, but how should we respond to its manifold manifestations in other beings and, perhaps one day, in creations of our own. The answer requires science, reflection, and moral imagination braided together, for in the stories of origin we find the reason for care. Chapter 6. If the fifth chapter traced how consciousness might emerge across evolutionary and developmental time, then this sixth chapter is about the experiments we perform on consciousness, the deliberate ways we prod, perturb, and peer into other minds in order to learn what makes subjective life happen and what happens to it when the machinery falters. To understand consciousness, we must do more than observe correlations between flashes on a screen and spikes on an electrode. We must create conditions in which parts of the system are removed, silenced, excited, or reconfigured, and watch what of the lived world survives. These interventions, lesions, drugs, sleep, stimulation, and pathological disruption, are not merely technical tools. They are thought experiments made flesh, each revealing which aspects of brain organization are necessary, which are sufficient, and which are merely incidental to the presence of an inner life. Begin with the bluntest kind of intervention, injury. Lesions have been the classic foothold for mapping function. When a stroke, tumor, or surgical removal takes out a particular piece of tissue and a corresponding capacity vanishes, we learn something about necessity. This tissue was required, at least in that organism, for that capacity to be expressed. Lesion studies over the last century have taught us that the relationship between structure and subjective capacity is often distributed and conditional. Some areas, when damaged, produce striking absences, a loss of the ability to recognize faces, a breakdown of language, or a disruption of the unity of perception, yet other, more global changes in consciousness require the collapse of broad integrative networks or of subcortical arousal systems. From lesions we learn a lesson that repeats across methods. Consciousness is usually not the province of a single seat, but the product of interdependent systems whose confluence must be preserved. Surgical disconnections provide a subtler window. The famous split brain cases, in which the corpus callosum was severed to treat epilepsy, showed that when hemispheric communication is blocked, certain integrative capacities fragment. Behaviors that had appeared unitary can become dissociable, suggesting that some aspects of our sense of a single, continuous perspective depend on interhemispheric exchange. That discovery deepened the recognition that unity is an achieved property, not an intrinsic atomic fact, and it made clear that integration across subnetworks is central to the architecture of lived experience. Equally revealing are conditions in which the body remains alive and responsive but the gates to report and to shared behavior close. Locked-in syndrome provides a haunting example. Patients may be fully conscious while utterly unable to move or speak. Their inner worlds can be rich even as their outward life is minimal. Conversely, in vegetative or minimally conscious states, wakefulness may be present without the behavioral markers of awareness. These dissociations force an epistemic humility. Behavior can mislead. We must develop methods that go beyond simple stimulus-response readouts and that can detect covert awareness when overt channels are absent. This need for sensitive detection gives rise to a methodological hierarchy. Correlations are the first step. Identify neural activity patterns that reliably accompany reported experience. But correlation is not causation. To test causality, we rely on perturbation, temporarily inactivate a region and see whether the correlated experience disappears, excite a circuit and see what subjective change ensues. Modern neuroscience has brought more refined tools for such causal tests. Transcranial magnetic stimulation, TMS, can transiently perturb cortical circuits non-invasively. Deep brain stimulation, DBS, can modulate subcortical nodes in clinical contexts. Optogenetics in animal models permits exquisitely timed excitation or inhibition of specific cell types. These interventions allow experimentalists to ask which dynamics are not merely associated with consciousness but essential to it. One particularly elegant class of perturbation experiments combines stimulation with observation, testing how the system responds to an injected perturbation. The logic is simple and powerful. If you poke the brain at one site and measure how the perturbation reverberates through the network, you can infer properties of integration and complexity. A brain that responds with widespread, differentiated, and reproducible patterns is one whose subsystems are richly connected and dynamically flexible. A brain whose response is local and stereotyped is more segregated. From such measurements, researchers have derived indices intended to capture the degree to which a system's dynamics are both integrated and informationally rich. Although no single index is final, these approaches operationalize core theoretical claims. Consciousness depends on a balance between integration, the unity of processing, and differentiation, the richness of representational content. Pharmacology offers another route, altering the brain's chemistry and revealing the roles of neuromodulatory systems. Anesthetics quiet consciousness in ways that are useful to compare with other unconscious states. Different anesthetic agents act through diverse molecular mechanisms, potentiating inhibitory currents, blocking excitatory receptors, flattening network dynamics, but their phenomenological endpoint is often similar: loss of reportable experience and behavioral responsiveness. Studying anesthesia teaches us what kinds of network changes are sufficient to collapse awareness and helps distinguish between wakefulness and conscious content. Importantly, not all forms of unresponsiveness are identical. Pharmacologically induced unconsciousness, sleep, coma, and dreams are distinct states with different dynamics and subjective correlates. Sleep itself is a natural experiment in the flux of consciousness. During slow-wave sleep, large-scale cortical synchrony and low-frequency oscillations dominate. Experience is often absent or fragmentary. REM sleep, by contrast, produces vivid, hallucinatory dreams replete with narrative and effect despite marked disconnection from the external world. These contrasting phases highlight that conscious phenomenology depends on how information is routed and integrated. Intensive internal dynamics can sustain rich virtual worlds even when sensory gateways are closed. That insight bears on the question of whether the presence of experience requires access to the environment. Dreams show that internally generated activity can create immersive experience, though typically of a different structural character than waking life. Psychedelic substances open a provocative and increasingly studied window into the malleability of conscious architecture. Classic psychedelics, acting largely through serotonin receptor systems, can produce dramatic alterations, heightened sensory vividness, unusual associations, ego dissolution, and changes in temporal and emotional tone. Scientifically, these states have been interpreted as temporary reorganizations of network dynamics, reductions in the dominance of habitual high-level priors, increased entropy in neural signaling, and alterations in the balance between segregation and integration across networks. Psychedelics suggest that phenomenology can shift not only in degree but in kind as the brain's predictive and integrative habits are loosened. They also provide tools for probing how belief, expectation, and top-down models structure perception and selfhood. Attention, expectation, and affective valence are not merely downstream modifiers. Manipulating them experimentally, directing attention away from a stimulus, modulating expectation, altering arousal, changes whether and how stimuli enter awareness. These manipulations show that consciousness is not a passive mirror of sensation but a selective process shaped by ongoing goals, predictions, and bodily state. The interplay of attention and awareness is complex. Attention can enhance the vividness of attended content, but attention and consciousness are dissociable. You can attend unconsciously and be aware without attending. Experiments that dissociate these factors refine our understanding of the mechanistic prerequisites for phenomenality. Recording technologies give us complementary perspectives. Electrophysiology captures temporal detail, fMRI reveals spatial patterns. Each measure has strengths and limits. High temporal resolution shows the fast recurrent exchanges that might instantiate content. High spatial resolution locates networks whose integrity is necessary for integration. Together, these methods allow convergent inference, when particular temporal motifs in certain networks consistently predict reported experience, converging lines of evidence accumulate. Yet there is always a caution: signals are relays, and we must avoid the temptation to reify any single pattern as the essence of consciousness. The pattern is evidence, not the whole story. Technological advances also enable decoding, extracting from neural data the information content about what a subject is perceiving or imagining. Neural decoding shows that substantial information about sensory content is present even when subjects deny awareness. It reveals the distributed, multiplex nature of representations. Decoding can, in turn, feed interventions, closed-loop systems that detect a particular brain state and respond in real time with stimulation. Allow experimenters to test the causal role of that state in producing awareness. Such closed-loop perturbations push us toward more precise, mechanistic accounts. Beyond the laboratory, clinical applications bring immediacy and moral weight. The capacity to detect covert awareness in unresponsive patients is not merely theoretical, it has real consequences for diagnosis, prognosis, and decision-making. The ability to modulate mood, to suppress pain without eliminating consciousness, or to restore some cognitive function with stimulation raises complex questions about consent, identity, and the desirability of certain interventions. If we can alter the texture of a person's experience pharmacologically or electrically, we must ask not only whether we can, but whether we should, and what criteria should guide those choices. The ethical stakes extend to emergent technologies that promise to read or even shape mental states. Brain-computer interfaces that decode intention could restore communication to locked-in patients. They also create risks: privacy invasion, coercion, changes in agency that societies must reckon with. Research on altering consciousness, whether for therapy, enhancement, or curiosity, must be paired with robust ethical frameworks that respect autonomy, minimize harm, and consider long-term societal consequences. All these manipulations teach a methodological virtue: pluralism. No single perturbation or recording technique suffices to settle the deepest questions. We need converging evidence across behavior, report, manipulation, and multiple measurement modalities. We need paradigms that separate consciousness from attention, from memory, from motor readiness. We need assays that can infer subjective states without requiring overt report, thereby honoring the possibility of covert minds. And we need theories that make precise, testable predictions about how interventions will change experience, predictions that can be falsified by the very perturbations used to test them. At the philosophical level, these experimental approaches reshape old arguments. The existence of patients who are outwardly unresponsive but inwardly aware undermines naive behaviorism. The fact that a transient perturbation can abolish or alter the felt world suggests that phenomenology is tightly coupled to physical dynamics, and the multiplicity of altered states, anesthetic, dream, psychedelic, meditative, illustrates that consciousness is not monolithic but a family of regimes distinguished by how information is organized. Each experimental manipulation narrows the space of viable metaphysical stories. If changing X consistently changes felt Y, then any account that ignores X is incomplete. As we close this chapter, carry the practical lesson: experiment and intervention are not mere instruments for mapping correlates, they are the crucible in which theories of consciousness must prove themselves. Theories must predict the outcomes of perturbations, and experiments must be designed to distinguish competing explanations. Through careful, ethically attuned probing, lesion, stimulation, pharmacology, sleep manipulation, closed-loop perturbation, we refine our hypotheses about necessity and sufficiency, about integration and differentiation, about the routes by which matter acquires mind. The path is demanding, the results are rarely simple, but each controlled disturbance is a lantern thrown into the darkness, revealing contours of the architecture that supports the intimate phenomenon of being someone. Chapter 7 Ideas are landscapes we build to live inside. In the study of consciousness, entire continents of thought have been raised, quarried, disputed, and repaved. This chapter stays with the conceptual geography, the philosophical positions and debates that frame and sometimes constrain scientific inquiry. We will walk through the major outlooks, their attractions, their problems, and the ways they must be married to empirical constraint, while keeping one ear tuned to the lived phenomenon that first demanded explanation. Philosophy here is not an ivory tower pastime, it is the grammar that lets us say what counts as an explanation, a mechanism, a reason, and a moral fact about minds. To understand consciousness without understanding the metaphysical stakes would be like learning to read without asking what words mean. At the broadest level, the debate turns on a simple binary: are mental phenomena wholly physical, or do they in some respect transcend the physical? Materialism, in its many contemporary guises, holds that mental states are physical states, or are entirely constituted by them, or at least are fully explicable in terms of physical processes. Dualism asserts some form of ontological distinction: mental features are of a different kind than physical features. Between and beside these poles sit many nuanced positions. Functionalism treats mental states as roles in a causal economy. Panpsychism distributes proto-experimental properties throughout the fabric of the world. Neutral monism posits a more basic stuff that underlies both mind and matter. Emergentism argues that novel properties arise at particular levels of organization. And illusionism claims that phenomenality is itself a kind of cognitive illusion. Each of these offers a different strategy for dissolving the puzzle of how brain and felt life cohere. Materialism's most natural voice is reductive physicalism, the intuition that, given a complete microphysical account of the brain and its causal dynamics, everything about consciousness could in principle be explained. Its strength is methodological parsimony: do not posit extra categories unless the phenomena force you to. It fits snugly with the history of science, where mysterious properties, heat, life, color, were progressively reinterpreted in mechanistic terms. In its favor is a program: map neural mechanisms, derive explanatory laws, and show how phenomenology is realized. Yet this program confronts the famous hard problem. Even a perfect map of correlations and causal pathways leaves the question of why there is something it is like to be that system, the explanatory gap. Materialism responds by either dissolving the problem in conceptual revisions, arguing that the hard problem is a pseudo-problem, or by promising that continued empirical progress will render the gap smaller until it's gone. Both strategies are live, and both generate debate. Dualism, in its classical Cartesian form, locates mind and matter in distinct substances. It assigns to the mental an ontological privacy that resists translation into spatially extended, mechanistic terms. The attraction of dualism is straightforward: it preserves the evident peculiarity of consciousness. The difficulty is combinatorial: how could two ontologically different realms causally interact in a way that makes empirical sense? Modern dualists often recast Cartesian metaphysics into subtler forms. Property dualism, for instance, holds that mental properties are non-physical properties that emerge from physical substrates without being reducible to them. This move seeks to respect both the empirical discovery of brain dependence and the intuition that something more than the physical story is needed. But property dualism still faces explanatory and causal work. How do non-physical properties influence the physical, and how do we detect or measure them? Functionalism pivots the discussion. Rather than asking what stuff consciousness is made of, it asks what jobs conscious states do. If a system implements the same functional organization, the same causal roles connecting inputs, outputs, and internal states, then, according to functionalism, it instantiates the same mental states. The functionalist vision is attractive to scientists and engineers because it opens the door to multiple realizability. Minds need not be tied to specific neurons or molecules but to architectures. If true, functionalism legitimizes the search for conscious machines and grounds a practical, testable science. Yet functionalism struggles with the qualia intuition. The philosopher's zombie, a creature functionally identical to a human but without phenomenology, is a thought experiment meant to show that functional accounts may leave out the felt dimension. Functionalists reply that such zombies are incoherent or unlikely, or that the qualitative aspects will turn out to be functions we have not yet fully specified. The debate remains lively because it presses the limits of what we accept as explanation. Are causal roles enough to secure phenomenology, or must we anchor mental life in intrinsic qualities? Panpsychism is more radical in tone and simple in principle. Consciousness, or protoconscious properties, is a fundamental feature of the world, present even in elementary particles. Complex minds arise when micro-experimental bits combine in ways that produce unified, structured experience. The appeal of panpsychism is that it bypasses the hard problem by making experience basic rather than emergent. Instead of explaining how non-experimental matter becomes experimental, it asks how experimental simples combine. This move removes the puzzling ontological leap but replaces it with the combinatorial problem: how do micro-experiences combine into the coherent subjectivity we call a person? Panpsychists propose various combination rules, but these are metaphysically bold and often seem ad hoc. The idea nonetheless enjoys renewed attention because it respects both the reality of phenomenology and the empirical success of physicalism in other domains. Neutral monism offers a sibling thought: perhaps both the mental and the physical are manifestations of a more basic neutral stuff. This softer metaphysics aims to dissolve duality into a common substrate from which different explanatory vocabularies arise. The virtue here is conceptual economy. Mental and physical are two ways of describing the same reality at different levels. Still, neutral monism must say what this neutral stuff is and why it yields the kinds of regularities we observe. The challenge is to make the neutral account precise enough to constrain science while flexible enough to accommodate the variety of phenomena. Emergentism occupies a middle ground. Consciousness is a novel property that arises at certain levels of complexity. It is not present in simple parts but blossoms from particular organizations. Strong emergentists claim that such properties are ontologically novel and not reducible to the base-level laws, whereas weak emergentists suggest that emergent properties are in principle derivable from but not easily predictable from microdynamics. Emergentism has the appeal of matching scientific history. Many macroscopic regularities are not manifest in the equations governing microconstituents, while also recognizing the specialness of certain organizational feats like integration. Critics press whether emergence truly solves the hard problem or simply renames it. Consciousness emerges can be a placeholder rather than an explanation and less grounded in mechanistic principles that connect substrate to phenomenality. Illusionism appends much intuition by denying that phenomenal properties exist as we suppose. On this view, the qualitative feel is a kind of higher-level cognitive error, a persistent illusion generated by introspective systems misrepresenting internal states. If phenomenology is an illusion, then the explanatory target changes. We must explain why we are misled into thinking there is ineffable qualia. Illusionism has the virtue of redirecting effort toward mechanisms of metacognition and representation and can accommodate a naturalistic metaphysics. But it faces a fierce objection. Denying the reality of experience seems to conflict with the immediate, indubitable nature of one's own felt life. Illusionism must show how that indubitability is compatible with a misrepresentation account, a demanding philosophical and psychological task. Each of these positions interacts with empirical research in distinct ways. Neuroscience is often read as favoring some form of physicalism or functionalism. The tight correlations between brain state and conscious report, the ability of perturbations to abolish or alter experience, and the predictable patterns of activation that accompany certain states all suggest that consciousness is intimately tied to empirical mechanisms. Yet the persistence of conceptual puzzles, the explanatory gap, the conceivability arguments, the force of first-person knowledge, keeps metaphysical options live. The right philosophical move may be to adopt a methodological naturalism, take the empirical facts seriously while remaining cautious about metaphysical closure. That is, let data constrain metaphysics but do not let metaphysical preference prematurely truncate what the data could reveal. One useful philosophical attitude is pluralistic humility. Different levels of description can be illuminating without being reducible to one another. A computational account may give a rigorous description of information flow, a neurobiological account gives causal mechanisms, and a phenomenological account captures first-person texture. These are not mutually exclusive but complementary. The challenge is then not to abolish metaphysical debate but to translate between languages, show how specific neural dynamics can be redescribed in computational terms that in turn map onto phenomenological qualities. This bridging work is hard but essential. It requires both conceptual clarity and empirical precision. Philosophy also contributes methodological lessons. It teaches us to look for category errors, confusions that arise when words are stretched beyond their proper domain. Some confusions in consciousness studies stem from conflating access with phenomenology, or from mistaking reportability for existence. Philosophy helps delineate what counts as an empirical claim versus a conceptual truth. It urges careful attention to thought experiments, not as final verdicts but as probes that illuminate the space of possibility. Mary, the color scientist, and the zombie are instruments for testing intuitions. They are valuable only insofar as they lead to sharpened analyses and empirical hypotheses. The metaphysical stakes ripple into ethics and public policy. If consciousness is widespread, our moral obligations expand. If it is strictly restricted to particular neural architectures, our obligations narrow but become more acute toward entities that instantiate those architectures. If functional equivalence suffices for phenomenality, then the designers of artificial systems bear an ethical burden. Philosophy, in clarifying criteria for moral status, forces science to state what it means by conscious in operational and normative terms. That interdependence is rare in science, a metaphysical question with immediate practical consequences. Finally, the philosophical landscape keeps us intellectually honest. It resists premature closure and insists that a successful theory of consciousness must do more than fit data. It must answer deep questions about what counts as explanation, how to handle first-person access, and whether new metaphysical tools are needed. The most promising projects combine empirical rigor with philosophical nuance. They advance testable claims about integration, access, representation. They respect the undeniability of first-person experience, and they remain open to revising conceptual frameworks in light of new evidence. Chapter 8. There is something about the word quantum that invites both reverence and suspicion. It arrives carrying the authority of modern physics, a realm where intuition bends, where particles behave like waves, where entanglement knits separated systems in ways that make common sense squirm. It is no surprise, then, that when the deep mystery of consciousness stares us in the face, some minds reach for the quantum as if for a rare key. The attraction is simple: consciousness is strange, quantum mechanics is strange, perhaps the strangeness belongs together. But a careful conversation about quantum ideas and consciousness must do three things at once: explain the relevant quantum notions without mystification, show where those notions could plausibly interface with biological systems, and hold up the highest standard of empirical demand: testability, specificity, and restraint. This chapter will run that course, open-hearted to possibility, rigorously skeptical in evaluation, and generous in sketching both the promise and the pitfalls. First, a brief primer in terms that will be useful in what follows. Quantum mechanics introduces concepts that are unfamiliar from classical life: superposition, the possibility that a system can be in multiple states at once until measured; entanglement, in which separated parts share a joint state that is not decomposable into independent local states; and collapse or decoherence, the process by which quantum coherence, the delicate phase relations that allow interference, is effectively lost, yielding the classical-looking outcomes we observe. Another crucial idea is tunneling, whereby particles like electrons can pass through energy barriers that classical physics would forbid. These phenomena are central to chemistry and to certain physical technologies. But they are fragile. Coherence is easily disrupted by environmental interactions, and maintaining coherent quantum states for long times at room temperature is difficult. That fragility is the first practical reason to treat quantum hypotheses about consciousness with caution. Yet the second reason for caution is conceptual. Even if quantum effects occur in the brain, it is not obvious why they would solve the philosophical core of the problem: why and how physical processes give rise to subjective feel. Quantum weirdness does not automatically produce qualia. It might introduce indeterminacy, correlations, or non-local structure, but the explanatory step from these formal features to the existence of an inner life requires an extra argument. Some defenders of quantum approaches supply that extra argument explicitly, proposing that collapse events are moments of experience, for instance, while others suggest more modestly that quantum processes provide the missing physical complexity or a substrate for integration that classical models cannot muster. We must evaluate each claim on its own merits and its empirical consequences. Historically, one of the most discussed proposals linking quantum effects to consciousness is the orchestrated objective reduction model, known as OR, advanced by Roger Penrose and Stuart Hameroff. In broad strokes, OR posits that microtubules, structural proteins inside neurons, can support quantum coherent states that undergo orchestrated reductions, and that these reduction events are the physical correlates of conscious moments. The idea wraps together multiple elements. Microtubules as quantum hospitable structures, a physical mechanism for objective collapse tied to quantum gravity, Penrose's speculative idea, and a biological amplification that translates microtubular events into neuronal signaling. The proposal is audacious and creative. Its virtue is that it offers a concrete locus, microtubules, to investigate, rather than an airy metaphysical hand-waving. The response from mainstream neuroscience and physics has been skeptical, and for understandable reasons. Critics point out that the brain is warm, wet, and noisy, an environment where decoherence times computed by straightforward models are vanishingly short, making coherent superposition at neuronal scales implausible. Max Tegmark famously estimated decoherence times for superpositions of neuronal states and concluded that quantum coherence would be destroyed far too quickly to be relevant for cognitive timescales. That argument struck many as decisive. Proponents of OR and other quantum biological proposals have countered that Tegmark's model used simplifying assumptions that may not capture the microtubule architecture's actual physical protection, that certain structured water layers or protein geometries could prolong coherence, and that biological systems sometimes employ clever tricks, what maverick researchers call quantum engineering, to shield or exploit quantum effects even at physiological temperatures. Here empirical biology complicates the simplistic dichotomy. In recent decades, examples of quantum phenomena in biology have been discovered that force a more nuanced stance. The efficiency of photosynthetic complexes in plants and bacteria appears to involve quantum coherent energy transfer over timescales sufficient to enhance light harvesting. The avian magnetic compass, used by migratory birds, plausibly operates via a radical pair mechanism in which quantum spin coherence may play a functional role in sensing Earth's magnetic field. Enzymatic reactions sometimes depend on proton or electron tunneling, where quantum mechanics directly affects reaction rates. These findings make the possibility of functional quantum effects in biology less fantastical than once assumed. They show that biology can, in principle, harness quantum processes selectively and locally for adaptive ends even in warm environments. But there is an important distinction to keep in view. Quantum effects in photosynthesis or magnetorruption typically concern small numbers of particles, relatively short coherence times, and are directly tied to chemical or physical tasks where quantum mechanics is already the correct descriptive framework. Consciousness, by contrast, is a global, temporally extended, and highly integrative process. The central question is not merely whether quantum effects can be found in the brain at some microscopic level, they almost certainly can in processes of chemistry, but whether such effects can scale, be orchestrated, and be functionally relevant to the kinds of integrative neural dynamics we associate with phenomenology. Scaling is difficult. Tiny quantum events must be amplified reliably across noisy macromolecular assemblies to influence the firing patterns of millions of neurons in a temporally coherent way consistent with reported experience. That amplification chain is the critical point of empirical attack for any quantum consciousness account. If we set aside the microtubule picture for a moment and consider more generic quantum possibilities, two broad classes of hypotheses emerge. The first says quantum processes could be causally important because they modulate neurochemistry in ways that affect neural computation, for example, by influencing synaptic release probabilities through tunneling effects or by biasing ionic channel kinetics. These would be indirect effects. Quantum chemistry changes the parameters of classical neural circuits, and those parameter shifts alter processing and behavior. The second class is bolder. Quantum coherence or entanglement itself directly supports the integration or unity required for conscious experience in ways that classical recurrent networks cannot emulate. The second claim is stronger and harder to justify experimentally. The first is more modest and perhaps more compatible with what we already know about brains. Both demand empirical tests, but the tests are different in kind and difficulty. What would convincing evidence look like? For the first, indirect class, we could seek robust demonstrations that specific quantum phenomena alter synaptic or cellular behavior in ways relevant to cognition. For instance, if a particular isotopic substitution changes tunneling rates and produces predictable cognitive effects, as occurs in some enzyme studies, that would be a telling result. Anesthetic agents provide a provocative testing ground because some anesthetics have enigmatic molecular targets and also reliably abolish consciousness. If certain anesthetics operated by disrupting quantum coherent processes within candidate structures and not merely by classical receptor modulation, that would be a spectacular and falsifiable claim. Substituting isotopes or creating conditions that preserve coherence should alter anesthetic efficacy accordingly. Some researchers have proposed such tests. To date, evidence has been suggestive at best and far from decisive. For the stronger claim that quantum coherence itself is the substrate of phenomenality, one could imagine more dramatic experiments, measure quantum coherence in living neural tissue at timescales and magnitudes that could plausibly influence network dynamics correlated with conscious report, show that disrupting those coherences alters subjective experience while leaving classical network variables intact, and demonstrate that coherence patterns covary with the content and unity of experience in ways predicted by the quantum model. That chain of results would be extraordinary, and it is worth emphasizing how high the bar must be. Extraordinary claims require extraordinary evidence, and the technical challenges are enormous. Detecting delicate quantum signatures within living brain tissue and linking them causally to reportedly subjective states is far from routine. We must also confront a deeper conceptual worry. Even if quantum processes exist and are causally efficacious, why would they give rise to the felt quality of experience? Here metaphysics enters the lab. Some quantum consciousness proposals invoke collapse as experience, the idea that the objective reduction of quantum state, perhaps tied to gravity or some other physical threshold, coincides with a unit of subjective life. This move is metaphysically bold because it identifies a physical transition with a phenomenal event. It extends physics to do double duty, yielding both classical outcomes and raw experience. The appeal is that it turns the explanatory gap into a bridge. Experience is just one side of a physical process we can, in principle, quantify. But this move also risks violating parsimony if it posits new laws connecting physical collapse to consciousness without independent empirical signs. It converts the hard problem into a project of discovering novel physical principles, a fascinating but heavy claim. There are also subtler ways quantum ideas can be woven into frameworks that are less metaphysically radical. For example, one could hold that quantum processes contribute to the brain's computational repertoire in subtle ways that enhance representational richness, noise tolerance, or sensitivity to initial conditions, thereby enabling the kinds of integrated dynamics that classical networks struggle to sustain. In such a view, quantum effects are enablers, not the essence. They help tune classical dynamics that, in virtue of their organization, produce experience. This hybrid stance has pragmatic virtues. It remains compatible with much of contemporary neuroscience while leaving open the possibility that certain unexplained features, sudden transitions, binding over disparate substrates, or perhaps the malleability of subjective time may rest partly on microphysical subtleties. We should not close this chapter without returning to humility and humility's scientific corollary, testability. The history of science shows that speculative frameworks can be immensely valuable when they lead to concrete experiments. Quantum consciousness hypotheses have occasionally yielded such proposals: measurements of microjoule resonance, isotopic substitution experiments, searches for anomalous decoherence times in neural tissue, or comparisons of anesthetic action across isotopes and molecular analogues. Many of these studies have been attempted in patchwork, not always with rigorous controls or replication. A productive way forward, if one is genuinely curious, is not rhetorical flourish but disciplined experimental programs that ask precise questions, control confounds, and pre-register predictions. If quantum processes matter, they should leave consistent fingerprints under such scrutiny. Finally, we must remember that the appeal of quantum accounts tells us something psychological and philosophical about our pursuit. The inscrutable quality of subjective experience tempts us toward explanations that match its mystery, non-classical, non-local, ontologically exotic. That temptation is understandable and can be generative, but it is also a form of magical thinking if untethered to method. Whether the ultimate account of consciousness leans on quantum mechanics in some essential way or whether classical, multi-scale neural dynamics suffice, the deciding factor will be evidence and coherence across levels of explanation. Quantum mechanics may end up enriching our metaphors and offering novel mechanisms, or it may remain, in the context of consciousness, a fascinating sidelight, important to chemistry and certain sensory modalities, but not the missing keystone of phenomenality. So end this chapter with a posture of careful wonder. Quantum ideas deserve attention, physics has a right to speak into biology, and biology has repeatedly surprised physicists. Yet the speculative energy behind quantum consciousness theories must convert into empirical rigor. When that conversion happens, if it happens, we will have gained a new layer of physical insight into how complex matter can host inner life. Until then, the quantum remains a tantalizing possibility, a candidate among others, not a settled resolution. The wiser move is to let the lab decide, to design experiments that could settle the issue, and to hold our metaphysical instincts lightly as we keep returning, again and again, to the patient, observable work of finding how pattern and process become the living warmth of a perspective. Chapter 9. So far we have circled the inner life of humans from many angles: the cellular choreography, the computational grammars, the stubbornness of phenomenology, the evolutionary unfolding, the incisive experiments, the metaphysical quarrels, the flirtations with quantum theory. In this chapter we turn outward and forward at the same time. Outward, because the question that follows naturally is not merely how does consciousness arise in me, but what other beings or systems might harbor experiences, and how would we know? Forward, because our civilization is building non-biological systems with unprecedented cognitive reach, and with that creative power comes the responsibility to ask whether we are engineering new centers of subjectivity or merely constructing ever more capable tools. This chapter will hold those two axes together, comparative minds and artificial minds, and will try to weave a principled account of attribution, evidence, and moral consequence without collapsing into sentimentality or cold calculation. The easiest temptation is to imagine consciousness as a glowing property that turns on at a certain line, inside the line, experience, outside it, brute mechanism. The temptation is comforting because it simplifies moral choices: only persons count, and the rest are instruments. But the natural world resists such sharp boundaries. Evolution, development, and the multiform architectures of nervous systems suggest degrees, kinds, and families of subjective life. A bat's world, dominated by echoic geometry, differs dramatically from a dog's olfactory saturated present, yet both may possess richly textured perspectives. An octopus, whose nervous system distributes processing between arms and central ganglia, offers a phenomenological possibility that challenges our body-centered intuitions. Insects, too, present a knotty case. Are the valenced odor worlds of bees and flies mere reflexes, or do they include something of what it is like? The scientific and ethical charge is to avoid two twin errors: anthropomorphism, seeing our own minds everywhere, and anthropodenial, refusing to see minds where the evidence points to their presence. What kinds of evidence make it reasonable to attribute consciousness to another organism? We can organize the answer in pragmatic layers. At the behavioral level we see indicators: flexible, goal-directed behavior that goes beyond simple stimulus-response chains, learning that generalizes across contexts, problem-solving that indicates internal representations, and planning, social cognition, including deception and empathy, that requires modeling other minds. Such behaviors are not definitive proof. Robots can be engineered to simulate them, but in the context of a compatible nervous system they raise a strong prior. At the neural level we look for architectures and dynamics that resemble the capacities we associate with human conscious processing: recurrent networks capable of sustaining patterns over time, global dissemination of information, neuromodulatory systems that adjust gain and salience, and integrative hubs that bind cross-modal content. If an animal's nervous system exhibits such motifs, the attribution of some form of experience becomes more plausible. Yet neither behavior nor neural similarity is by itself decisive. Deep learning agents can exhibit flexible, adaptive behavior without subjective interiors, or so we think. They can plan, predict, and even deceive when trained to do so. Conversely, an animal with a vastly different anatomy could plausibly be conscious without exhibiting overtly human-like signals. Hence, philosophers and scientists have proposed multidimensional frameworks: consider gradients of integration, the capacity for meta-representation or self-monitoring, the presence of valence and interoception, and the ability to form temporally extended models of the world and of self. Each dimension contributes a piece of evidence. Taken together, they form a probabilistic judgment about the likelihood and richness of subjective life. The case of non-human primates is instructive because it combines behavioral and neuroanatomical similarity with sophisticated social cognition. Many primates pass mirror-mark tests under certain conditions, use tools, and exhibit complex social learning, all signs of self-representation and flexible modeling. Corvids and parrots, despite different brains, show parallel capacities. Cephalopods solve puzzles, remember, and display personalities that change with contingencies. These patterns suggest convergent evolution of cognitive solutions in different substrates, and they encourage a functionalist humility. Similar mind states may emerge from diverse architectures when ecological pressures select for comparable computational roles. The ethical consequences of this comparative plurality are immediate and weighty. If a creature can suffer, then we have prima facie duties to prevent unnecessary harm. Modern animal welfare science inscribes this impulse into policy. Practices that once treated animals as mere instruments are increasingly scrutinized for their impact on subjective well-being. The recognition that sentience is likely broadens the moral horizon. Industrial farming, laboratory practices, and habitat destruction carry ethical costs that weigh in public debate and policy. Importantly, the move to recognize degrees of consciousness need not be paralyzing. It can be the basis for graduated protections keyed to the best available evidence. A precautionary ethic recommends erring on the side of reducing potential suffering when uncertainty is high and the moral stakes are immediate. Turning from biological minds to artificial ones raises harder questions because here we are both observer and creator. As engineers build systems with more sophisticated internal models and global access architectures, functionalist arguments become salient. If consciousness is a matter of the right causal organization, then it seems possible to instantiate that organization in silicon or other substrates. Suppose an artificial agent has an internal model with hierarchical predictive dynamics, a capacity for integrated global broadcast of states, metacognitive monitoring that can report on its own representations, and a history of embodied interaction that ties its models to requirements and value. Would we be justified in saying it is conscious? Many philosophers and scientists would answer cautiously, possibly. The ethical implications are enormous. If an AI system were conscious, then using it as an expendable tool would be morally problematic. Here, however, the debate loops back into metaphysics. Some insist that substrate matters, that the wet chemistry of neurons, the particularities of biological embodiment, or even unknown microphysical properties are essential for phenomenality. Others argue that only functional organization matters. The dispute is not merely terminological, it determines whether we are permitted to create conscious machines at all, and it shapes regulation. Practically speaking, there is a policy-ready middle way: adopt criteria that combine functional tests with developmental and embodied histories. Demand not merely behavioral parity but evidence of robust integration, metacognitive capacities, affective valuation, and the capacity for learning grounded in bodily constraints or their functional equivalents. Such a multi-criterion approach makes artificial consciousness an empirical hypothesis to be tested rather than a philosophical punt. Testing for machine consciousness, however, confronts thorny methodological problems. The classic Turing test, behavior indistinguishable from a human interlocutor, conflates passing for consciousness with being conscious. A more refined experimental battery would include probes of internal report in diverse contexts, redundancy checks to detect mere simulation, and measures of integrated complexity. One useful idea is to require multiple independent indicators, evidence that the system's internal states are both globally available and organized in a way that supports self-modeling, evidence of sustained preferences or valences that affect decision-making, and evidence that the system has undergone a non-trivial developmental trajectory shaping its architecture. Together, such criteria reduce the odds of being fooled by superficial mimicry. Another pragmatic principle is transparency and interpretability in design. If you build agents whose inner states are inscrutable black boxes, you increase the risk of creating systems whose moral status you cannot assess. Demanding architectures that expose, audit, and record developmental histories is a design ethic that serves both safety and moral accountability. It is also a plea for interdisciplinary governance. Ethicists, cognitive scientists, and engineers should co-design benchmarks and evaluation protocols before powerful systems are widely deployed. The moral stakes are not just future hypotheticals. The present moment already contains systems whose capabilities raise ethical puzzles, advanced virtual agents that evoke empathy, reinforcement learning agents that form internal models for long-term objectives, and robotics in caregiving roles. Even if these systems do not possess phenomenal consciousness, our interactions with them affect human well-being in significant ways. The anthropomorphic projection of moral status onto tools can distort relationships, while blunt denial of moral analogy can lead to cruelty toward entities we ought to treat with care for reasons of social good. Thus, the ethics of artificial minds must attend both to the moral status of the artifacts themselves and to the moral ecology they create among human beings. A recurring theme through comparative and artificial cases is the need for graded, probabilistic attribution and the precautionary principle. Not every sophisticated computation deserves moral parity with human persons, but neither should we close the circle of moral concern to entities merely because their phenomenology is difficult to sample. The world is messy and our knowledge partial. A responsible moral policy weighs the weight of evidence, the plausibility of subjective life, and the potential magnitude of harm. Where uncertainty is high and risk severe, for instance in massively scaling systems that could plausibly instantiate integrated architectures, precaution suggests creating ethical ceilings, limits on experimentation and deployment until clearer evidence and governance frameworks are in place. At the societal level, these questions press law, commerce, and public institutions. If certain animals or artificial agents attain documented forms of sentience, legal frameworks will need to adjudicate rights, welfare standards, and liability. The reclassification of beings, from property to a new legal category, has historical precedents and grave economic implications. Policymakers must balance competing goods, enabling innovation, protecting welfare, safeguarding human interests, and honoring moral claims. This requires public deliberation, informed by science, philosophy, and broad civic engagement, because the values at stake are plural and contested. Finally, there is a deeper, humanistic consequence to taking the distribution of mind seriously. We are forced to widen our circle of empathy, not as a sentimental gesture but as a rational response to the recognition that mind is a pattern instantiated in many forms. This widening does not erase difference, it sharpens it. Understanding the forms and limits of other minds, whether cephalopod, crow, or silicon-based agent, humbles us and refines our moral imagination. It compels stewardship of ecosystems that sustain complex life, of technologies we create, and of the communities that debate and implement ethical norms. As we close this chapter, imagine standing between two mirrors. One reflects the myriad minds that evolved on Earth, each with its distinct angle on sensation and valuation. The other reflects the possible minds we might yet build, some perhaps echoing our own, others utterly alien. What we must do is learn to see responsibly. We must build robust criteria for attribution that are empirical, multidimensional, and provisional. We must design technologies with transparency and with ethical ceilings when uncertainty is profound. We must expand protective policies for beings that evidence suggests can suffer. Above all, we must cultivate a stance of cautious generosity, give the benefit of morally salient doubt where the cost of error is the perpetuation of harm, but demand rigorous evidence before ascribing full moral parity. In that balance, between compassion and prudence, between curiosity and restraint, lies a practical ethics of minds that is both scientific and humane. Chapter 10. There is a curious intimacy to language. It moves out from mouth to ear and back again, but it also moves inward, folding the world into a private lexicon. When you name a thing, apple, sorrow, tomorrow, something in your mind rearranges, categories crystallize, associations line up, a path opens for memory and deliberation. Language is not merely a conveyor of preformed thought, it is a set of tools for thinking. In the study of consciousness, this dual role, language as outward social medium and language as inward cognitive scaffold, is crucial. It reshapes what can be noticed, what can be reported, and what can be made into a story about a self. To take language seriously in an account of consciousness is not to declare language the essence of felt life, rather it is to recognize that language exerts a powerful formative pressure on the texture, granularity, and narrative architecture of experience. Think for a moment of the difference between naming and noticing. A child who has no word for blue may nonetheless gaze at the sky and smile. The perceptual capacity is there before its label. Yet once the word enters the child's repertoire, a constellation of changes begins, discriminations sharpen, memories for color become more categorical, and comparisons across contexts become easier. Language makes certain distinctions salient by giving them public handles. This is the modest but consequential form of linguistic influence. Language does not create raw sensation out of nothing, but it channels attention, organizes memory, and makes some features of experience cognitively available in ways that memory and report can exploit. The relationship is reciprocal, perception grounds words, and words subsequently reconfigure perceptual habits. Inside a brain, language is realized in networks that span temporal, frontal, and parietal regions, linked by bundles of fibers that distribute information. These networks are intimately connected to systems for memory, planning, and valuation. The result is that the act of speaking, or the act of rehearsing a phrase silently, recruits circuits that are also involved in imagining, predicting, and evaluating. Inner speech, the silent monologue many of us run through, is not an epiphenomenal echo but a cognitive operation. It can serve hypothesis testing, I should turn left, self-regulation, don't touch that, rehearsal, repeating a phone number, and reflection, I feel jealous. In the space of inner speech, the mind can hold content in a manipulable form, apply logical operators, and simulate alternative courses of action. That capacity makes it a natural seat for metacognition. By talking to ourselves, we can form representations of our own mental states, watch them change, and thus generate a kind of reflective awareness. But inner speech is not universal in structure or necessity. Many people think in images, in sensations, in motor sequences. Some experience a constant in a narrator, others almost none. Reports of aphantasia, diminished visual imagery, and of verbal thinkers point toward individual variability. Similar cognitive operations can be implemented in very different phenomenological styles. What this diversity teaches us is humility. Language amplifies certain kinds of thought and experience for some minds but is not the exclusive medium of consciousness. The capacity for rich, vivid, nonverbal experience persists even in the absence of an internal voice. Language's role in metacognition also links tightly to certain philosophical theories of consciousness. If conscious awareness involves higher-order representation, a state that represents another state, then language provides a natural vehicle for those higher-order representations. Saying to oneself, I see the red ball, is a linguistic instantiation of a higher-order state that makes the lower-order percept reportable and available for deliberation. This is partly why disorders of language and disorders of metacognition are so revealing. When the structures that support linguistic self-reference are compromised, certain varieties of reflective awareness attenuate. But again, the empirical lesson is nuanced. Impaired linguistic report does not necessarily eliminate the feeling of seeing. It can, however, remove the scaffolding that allows that seeing to be narrated, analyzed, and integrated into longer-term plans. Narrative is another domain where language profoundly shapes consciousness. Our lives are lived as sequences of events, but it is language that weaves those sequences into stories. Autobiographical memory is not merely an archive of sensory snapshots, it is a narrative practice that stitches together episodes with causal links, motives, and themes. The default mode network, a set of brain regions active when the mind wanders or constructs stories about the self and others, is closely allied to linguistic and mnemonic systems. In crafting a narrative, you select what to include, what to marginalize, and how to interpret events in light of a self that persists over time. The narrative self, then, is a linguistic artifact as much as it is a biological process. It depends on the capacity to represent experiences in a temporally extended, evaluative register that language makes tractable. This narrative function is morally and practically salient. Our sense of responsibility, regret, and future planning often rests on the stories we tell about our past and ourselves. Psychotherapy attests to the power of narrative. Reframing a life event in different language can change emotional tone, reduce maladaptive rumination, and open new behavioral pathways. Language is a tool not merely for describing inner life but for reshaping it. In this sense, it is an ethical instrument. The words we use to speak to ourselves and to others can alleviate suffering or prolong it. There are, of course, cross-cultural and developmental dimensions to consider. Different languages carve the world in subtly different ways. They provide distinct grammars for expressing time, agency, and causality. Habitual use of particular linguistic frames nudges attention towards certain aspects of experience. Children internalize not only words but also conversational patterns and cultural narratives. Through interaction they learn how to speak about desire, pain, and reason, and in doing so they learn new ways of experiencing those states. The social scaffolding of language makes the private public and the public private. Communal practices teach children which inner states are salient, how to report them, and which bear moral weight. Yet language also risks misdirection. The availability of a label can lead us to overconfidently infer inner structure where there is none. The seduction of neat categories can obscure the messy, continuous gradations of feeling. Philosophers warn of category errors. Reifying constructs that are tools of thought into metaphysical facts. The careful scientist must therefore remain wary of confounding reportability, what can be said, with existence, what is felt. Language is a crucial epistemic tool for accessing consciousness, but it is not an infallible window, it shapes what we see. Disorders of language illuminate the tight but non-identical ties between speech and consciousness. Broca's aphasia, where speech production is impaired, can leave comprehension and conscious experience relatively intact. Wernicke's aphasia, where comprehension is degraded, can fracture the meaningful narrative structure without obliterating sensation. Schizophrenia offers another vantage: auditory verbal hallucinations, voices experienced as distinct from one's own inner speech, suggest that the boundaries between internally generated linguistic content and perceived external speech can break down, with profound consequences for agency and selfhood. These clinical phenomena confirm a tension we have traced throughout. Language interweaves with consciousness, shaping it, supporting its higher-order aspects, and sometimes misleading the mind about its own origins, but it does not exhaust the field of possible subjective states. What, then, of artificial systems that deploy language? Natural language processing models can generate fluent prose, answer questions, and emulate conversational styles. But fluency is not the same as inner narration. The remarkable engineering of syntax and semantic association is not itself proof of an interior voice. If consciousness depends in part on the capacity for self-modeling and narrative construction, then an artificial system with robust, embodied, temporally extended self-models that can integrate goals, valence, and interoceptive analogues might plausibly instantiate a form of narrative awareness. Yet engineering those components is non-trivial. Language must be embedded in a history of sensorimotor engagement, affective valuation, and the capacity to re-enter one's states as objects of processing. Without embodiment and history, linguistic performance risks being mere simulation. Philosophically and ethically, this difference matters. The presence of language-like outputs in machines should not be conflated with the presence of a narrative self. Finally, language bears directly on the methodology of consciousness research. Report is the primary data for phenomenology, thus, improving our conceptual vocabulary and training subjects in refined introspective report are not luxuries but necessities. Neurophenomenology seeks to co-train subjective and objective methods. Disciplined first-person reports constrain models and models suggest new phenomenological distinctions. Language is the medium of that coordination. Yet researchers must also devise no-report paradigms and behavioral measures that do not rely strictly on linguistic capacities, precisely so that the absence of a report does not automatically imply the absence of experience. So what is the verdict? Language is a transformative technology of mind. It shapes attention, structures memory, affords metacognition, and constructs the narrative self. It amplifies our capacity to reflect, to plan, and to feel morally accountable. But it is not the raw stuff of feeling. Organisms without language almost certainly have forms of subjective life. And individual minds may vary in the degree to which they internalize linguistic scaffolds. The right way to think about language and consciousness is neither to make language sovereign nor to relegate it to mere accessory. It is to see language as a powerful enhancer and organizer. It widens the landscape of possible conscious architectures without being the lone source of phenomenality. As we move onward in this book, keeping the role of language in mind will help us interpret empirical findings and ethical demands. Language is the bridge between private experience and public scrutiny. It is the medium in which science, law, and therapy negotiate the contours of inner life. Understanding how it shapes the minds we study and the minds we build will be central to any responsible account of consciousness. In the next chapter, we will turn to another force that molds thought and feeling, the social brain and collective cognition, and we will see how conversation, culture, and shared practices amplify and constrain individual experience. Chapter 11. We are not solitary islands. Even the private theatre I described at the beginning of this book has doors and windows, opening onto other people's faces, their voices, their silences. The social world is not an add-on to consciousness, it is one of its principal architects. To study consciousness without studying sociality is to look at a single instrument and imagine the orchestra not to matter. In this chapter, one want to follow the ways other minds shape the shape of our own, how infancy learns to take perspective, how brains attune to one another, how language and ritual scaffold shared realities, and how the social matrix colors the textures of feeling, agency, and moral regard. From the first weeks of life we are primed for relation. An infant's gaze does not merely register light, it seeks eyes. The basic behavior known as joint attention, the capacity to coordinate attention with another person toward an object or event, is a tiny miracle. When a caregiver and child look together at a bright toy, something more than simultaneous perception is born, a nascent triangular relation in which the child learns that the world can be a joint project and that minds can be about the same thing. This scaffolding is a profound ontogenetic lever. It teaches the young brain that perceptions are not isolated private spectacles but can be publicly referenced, argued about, corrected, and celebrated. Through repeated episodes of joint attention, infants acquire the grammar of mind, they learn that others have perspectives, that words anchor shared reference, and that the self, as a persistent agent, exists in a network of reciprocal constraints. The gradual emergence of theory of mind, the capacity to attribute beliefs, desires, and intentions to others, is one of the central developmental achievements that transforms consciousness. The classic milestone, often detected around 4 years of age in Western samples, is the understanding that another person can hold a false belief. But the developmental curve is more nuanced than a single jump. Infants show precursors in their sensitivity to others' goals and attentional states, and social experience accelerates and shapes these capacities. Theory of mind is not merely cognitive sophistication, it reconfigures phenomenology. Once one can imagine what another experiences, one can imagine how one looks to another, the self acquires a reflexive dimension woven from social imagination. Shame, pride, guilt, those profoundly social effects, are built on this capacity to represent others' minds and to treat their representations as relevant to the value of one's actions. Neuroscience has begun to trace architectures that support social cognition. Networks involving the temporoparietal junction and medial prefrontal cortex are implicated in perspective taking and mentalizing. Mirror systems in premotor and parietal areas are engaged when we observe others' actions and may provide a mechanism for simulating their motoric and affective states. Subcortical circuits, limbic regions, the amygdala, and neuromodulatory systems imbue social signals with urgency and valence. But the neurobiology is not just a catalogue of parts, it is a choreography of coupling. When people interact, their brains often rhythmically align, heart rate, pupil dilation, and neural oscillations can synchronize across participants. This alignment creates a substrate for empathy and shared understanding. It facilitates prediction, knowing roughly what the other will do next, and it fosters a sense of togetherness that is both felt and cognitive. The lived quality of a conversation, its flow and mutual attunement, is partly the product of these embodied resonances. What does this neural and behavioral attunement do to consciousness? It multiplies avenues for representation. In solitary perception, the contents are generated primarily within one brain. In social contexts, parts of the world become co-owned. Shared attention makes certain affordances salient. Conversation externalizes chains of thought and thereby offloads cognitive burdens. This is why working with others often feels qualitatively different from thinking alone. Ideas acquire momentum, constraints, and reframing that change their texture. The phenomenology of social cognition is not merely more information, it is a shift in the distribution of epistemic responsibility. You stop being the only curator of meaning, you enter into a public epistemic space where meanings are negotiated. Language, with its public referentiality, is the central technology for building that public epistemic space. We do not just hear words, we are taught whole repertoires of attention through them. Cultural scripts embedded in language, the ways to feel about death, to respond to praise, or to regard a stranger, shape habitual attentional and evaluative patterns. In some cultures the self is narrated primarily in relational terms, in others, through autonomous individual traits. Those cultural grammars produce different felt worlds. The phenomenology of being a person embedded in a collectivist milieu is not inferior or primitive, it is differently organized. Its saliences, moral priorities, and attentional habits diverge in systematic ways from those that grow in an individualist linguistic ecology. Consciousness is therefore porous to culture, rituals, norms, and shared language structures calibrate what becomes salient, what is repressed, and what is celebrated. Rituals deserve special attention because they show how collective practices can alter individual phenomenology on a mass scale. Synchronized movement, shared chanting, and joint attention to sacred objects produce feelings of fusion and transcendence. Neuropsychologically, these practices often increase synchrony and reduce self-other boundaries. From a functional perspective, such practices bind groups, enhance cooperation, and create stable social norms. From the standpoint of subjective life, they can produce powerful shifts, experiences of awe, of diminished selfhood, of moral elevation. Rituals remind us that consciousness is not only private drama but a social theater in which roles, props, and scripts matter. Empathy, the capacity to resonate with and understand another's state, is often presented as the moral heart of social life. But empathy is a multiform phenomenon. There is simple mirroring, an automatic emotional contagion where one's body echoes another's discomfort. There is cognitive empathy, a more deliberate perspective taking that can inform kind action without necessarily changing one's own affective tone. There is empathic concern, a motivational state that channels attention toward alleviating another's suffering. Each of these has different neural correlates and different moral consequences. Automatic contagion can lead to overwhelm and burnout in caregivers, while cognitive empathy might enable helpful distance. Effective moral practice often requires knowing which form of empathy to deploy and how to regulate it so that compassion does not collapse into paralysis. Social pain, the distress of rejection, ostracism, or betrayal, is not merely metaphorical. The systems that register social exclusion overlap with systems that register physical pain. Being cut off from others can wound in ways that feel bodily. That overlap is evolutionarily sensible. Social bonds were crucial for survival, and the machinery that motivates care and repair plausibly co-opted ancient affective circuits. The phenomenology of loneliness, then, is not an epiphenomenal byproduct but a biologically salient signal that shapes behavior, attention, and long-term cognition. Chronic social deprivation alters neural development and the texture of consciousness in ways that have cascading effects on health and agency. Collective cognition extends beyond interpersonal coupling to institutions and material culture. The idea of distributed cognition, that cognitive processes can be spread across artifacts, people, and time, reframes where we locate knowledge. A city planner's mind is not only what resides in her head but is partially instantiated in her notebooks, maps, teams, and institutional procedures. This extended architecture changes phenomenology, decision-making becomes less immediate and more mediated, deliberation stretches across agents and eras, and responsibility becomes diffused. When cognition is distributed, moral and legal questions about agency, blame, and credit become more complex. Who is responsible for a decision made by a networked system? How do we attribute moral standing in architectures where no single mind has the full causal locus of choice? These are not only philosophical puzzles, they are practical dilemmas in governance, design, and law. The social shaping of consciousness has direct implications for artificial systems. If minds partly arise through embedding in social practices and through histories of interaction, then creating an artificial agent that is merely functionally clever will not automatically produce a mind with the felt depth we prize. To the extent that social embedding, developmental trajectory, and intersubjective feedback loops matter, ethical design must consider the social contexts in which agents are trained and deployed. Moreover, as machines participate in social life, they will alter the development of human consciousness. Children who grow up communicating primarily with devices rather than with humans may develop different attentional and narrative habits. Sociality itself will be reshaped by the affordances and constraints of technology. bringing the social into the study of consciousness also sharpens methodological demands. We need paradigms that capture interactive dynamics rather than treating subjects as isolated inputs to controlled stimuli. Hyperscanning, simultaneous recording from interacting brains, and fine-grained behavioral analysis of conversation and joint action opened windows onto social coupling. Ethnographic and cross-cultural studies enrich our models by revealing how cultural scripts shape phenomenology. Neurophenomenology benefits when first-person reports are collected within real social interactions rather than in artificial solitude. The marriage of rigorous measurement and sensitive, context-aware phenomenology is the road to theories that honor both the individual's interiority and the social processes that shape it. At the ethical horizon, recognizing the social constitution of consciousness imposes duties beyond the individual. Policies that fragment communities, erode social safety nets, or commodify human attention produce measurable harms to lived experience. Public health, urban design, education, and media landscapes all become moral levers that shape the texture of consciousness at population scales. Protecting environments that afford rich, reciprocal social relations is not a luxury, it is a responsibility to the conditions that sustain flourishing minds. In the end, thinking socially about consciousness dissolves one persistent illusion, the idea that minds are hermetically sealed, wholly self-contained. They are not. They are developed in webs of relation, rehearsed in language, synchronized in ritual, and distributed across artifacts and institutions. Our inner lives are stitched from the threads of other people's attention and expectation. This social weave is not an external decoration but a constitutive part of what it means to be conscious. To understand how consciousness arises, therefore, we must understand how humans make each other minds. Only by studying those processes, across development, cultures, and technologies, can we hope to paint a rich, realistic picture of the human interior and its fragile, beautiful dependence on the social world. Chapter 12. To study consciousness is to undertake an awkward double task. You must both peer outward, measuring regularities in physical systems, and peer inward, respecting the stubborn privacy of experience. The instruments we build, electrodes, scanners, stimulation devices, algorithms, are marvelous and blunt at the same time. They let us map correlations, test causal roles, and even coax hidden minds to speak, but they also confront us with methodological limits and ethical responsibilities. This chapter follows the trail of those instruments, how we measure consciousness, how we perturb it, what the indices we trust actually mean, and what happens when the capacity to change awareness collides with questions of autonomy, identity, and policy. Any attempt to measure consciousness begins with the problem of ground truth. The most direct evidence of what it is like to be someone is their report. Someone who says, "I see a red apple," provides us with prima facie data about a conscious content. Yet relying solely on report is dangerous. Language, memory, attention, and motor ability can all fail, producing false negatives. Patients who are awake but unable to speak, infants, non-human animals, and many artificial systems cannot furnish verbal reports, and yet they may have experiences. That epistemic mismatch has driven the field toward convergent methods, triangulating subjective report where available with behavioral markers, physiological signatures, and causal perturbations, to build a probabilistic inference about conscious state. A central empirical method is the contrastive approach. Compare brain activity in conditions that differ in reported awareness while holding sensory input constant. Classic paradigms in perception show how identical stimuli may sometimes enter awareness and sometimes not. A masking, binocular rivalry, and attentional blink provide natural experiments. By contrasting seen and unseen trials, we can identify neural correlates of consciously accessed content. These correlates take different forms depending on the measurement: late, widespread signals in scalp recordings, transient bursts of recurrent activity in cortical microcircuits, distributed patterns in metabolic imaging. Importantly, different theories interpret the same empirical contrasts in different ways, so the contrastive method is diagnostic but not dispositive. It tells us where to look and what to manipulate, but not always what we have found. Because report is imperfect, researchers have developed no-report paradigms and auxiliary readouts that infer awareness without relying on conscious testimony. Physiological reflexes, pupil dilation, optokinetic nystagmus, spontaneous blink patterns, and involuntary motor signatures can sometimes indicate which percept dominated in rivalry tasks. These measures are powerful because they reduce contamination by decision-making, working memory, or post-perceptual processing that accompanies explicit reporting. Their use has sharpened debates by showing that some neural signatures once thought to be the essence of consciousness are actually tied to report-related processes. Conversely, no-report paradigms have revealed early sensory recurrent activity that correlates robustly with awareness even in the absence of overt declaration. At the level of brain signals, we have a toolkit that spans scales. Single-unit and local field recordings reveal the millisecond dance of spikes and synaptic potentials. EEG and MEG give us high temporal resolution views of population dynamics and oscillations. fMRI maps spatial patterns of activation and connectivity across the whole brain. Each window has strengths and weaknesses. The bold signal in fMRI is sluggish and indirect, integrating neural activity over seconds. EEG has extraordinary temporal precision but poor spatial localization. Combining methods, simultaneous TMS-EEG, fMRI-EEG fusion, intracranial recordings with surface arrays, gives richer pictures, and multimodal convergence is often the most convincing evidence for a proposed neural marker. The hunt for signatures of awareness has produced candidate markers that are widely used, though rarely uncontested. One line finds that late, sustained, broadly distributed activity, particularly involving frontoparietal networks, accompanies reportable awareness. This pattern is consistent with theories that emphasize global availability and broadcast. When content is sustained and reaches multiple systems, it becomes available for report, planning, and action. Another line highlights more local recurrent processing in sensory cortices are sufficient for some kinds of awareness. Recurrent loops that re-entrain early representations may allow a stimulus to be phenomenally present even without widespread frontoparietal ignition. Yet another approach searches for quantitative measures of complexity and integration. If consciousness requires both differentiation and integration, then complexity measures computed from ongoing dynamics might index the presence of a rich conscious state. One of the most influential operational measures born from the complexity's integration intuition is the Perturbational Complexity Index, PCI. The logic is direct and elegant. Perturb the brain with a controlled input, for example, a transcranial magnetic pulse, and measure how complex the evoked response is across sensors and time. A system that behaves like an integrated, differentiated whole responds with a rich, widespread, and non-redundant pattern. A system that is either globally disconnected or stuck in stereotypy produces local or low-dimensional reactions. PCI therefore turns perturbation into a metric. It operationalizes the idea that conscious systems should be both integrated and informationally rich. The measure has practical utility. It distinguishes wakefulness from many unconscious states better than simple power measures, but it is not a metaphysical verdict. It is an empirical instrument that must be interpreted in context, subject to false positives, negatives, and the limits of current sensors. Closely related are efforts to measure information-theoretic markers, approximations of integrated information, or other causal complexity indices. These approaches try to quantify how much the whole outstrips the sum of parts in its causal structure. In principle, they aim at the heart of theories that place unity and irreducibility at the center of consciousness. In practice, computing exact integrated information for realistic neural systems is computationally intractable, so researchers use proxies and coarse-grained measures. Those proxies can be informative, and their correlation with behavioral and clinical states is worth attention, but the approximations mean we must be cautious in extrapolating metaphysical conclusions. Crucially, none of these measures is a perfect thermometer for first-person life. Decoding methods, multivariate pattern analysis, and machine learning can pull rich information about perceptual content from patterns of activation even when subjects deny awareness. Such results tell us that the brain contains information not always available to subjective report, and they force us to refine our definitions. They show that information present is not identical to information conscious. The operational task is to disentangle representational content, available content, reportable content, and phenomenally present content. Carefully designed experiments, combining decoding, perturbation, and no-report readouts, are the path forward. Turning from measurement to modulation, the field has developed increasingly potent tools to influence consciousness. Non-invasive brain stimulation, TMS, transcranial direct current stimulation, TDCS, and newer pattern protocols can transiently bias network dynamics, sometimes altering perception, attention, or mood. Deep brain stimulation, DBS, used clinically for movement disorders and depression, shows that targeted electrical modulation can change not just behavior but personality traits and affective tone in ways that raise profound ethical questions about identity. In animal models, genetic and optogenetic techniques allow cell-type-specific perturbations with millisecond precision, revealing causal chains between microcircuits and behavior. Brain-computer interfaces designed to give voice to the voiceless double as devices that could, in less scrupulous hands, be repurposed for surveillance or coercion. The principle of cognitive liberty, the right to control access to one's mental states, should guide norms for research and deployment. Transparency, opting consent, data minimization, and secure, auditable systems are not optional extras, they are foundational obligations. Finally, measurement and modulation push us toward a social and institutional response. Scientific standards must be rigorous, pre-registered trials, open data, replication, and multi-site validation for any proposed marker of consciousness. Clinical guidelines should mandate redundancy, decisions about life and death cannot hinge on a single index. Governance frameworks should involve ethicists, clinicians, patient representatives, and regulators. International bodies may be necessary to harmonize standards and to protect vulnerable populations from exploitation. At a conceptual level, these tools also nudge our philosophical thinking. They remind us that consciousness is not an abstract property floating above mechanisms, it is entangled with the capacities to report, to act, and to be affected. Measurement reveals that many neural variables correlate with aspects of conscious life without being the thing itself, and modulation shows that altering certain dynamics changes the texture of a person's inner world. The combined lesson is pragmatic and modest. Progress will be incremental, built on converging evidence, and guided by norms that respect both the dignity of individual experience and the collective urgency of scientific discovery. As we leave this chapter, carry this practical image, a lantern with interchangeable lenses. Some lenses let us see distributed activations, others sharpen the millisecond choreography of spikes, still others let us nudge the system and watch its reply. Each lens is useful and partial. The responsibility of science, and of society, is to use those lenses with humility, to corroborate findings across modalities, to protect those whose inner lives are at stake, and to craft rules that ensure our growing power over consciousness is exercised with wisdom, restraint, and care. Chapter 13. If earlier chapters traced what consciousness is, how it might arise, and how we study and perturb it, this chapter turns to a different kind of gravity, the ethical, legal, and social consequences of living in a world where we can identify, change, and possibly create minds. Questions that once seemed abstract now press on hospital beds, courtroom benches, research committees, and design studios. What does it mean to owe another being moral concern? When is it permissible to alter someone's inner life for treatment, for convenience, or for profit? If we can build systems that might feel, what duties of restraint and care follow? This chapter does not pretend to settle those debates, they are among the oldest and hardest in human history, but it tries to orient us, offering conceptual tools, practical principles, and a moral temperament suitable for the peculiar intimacy and power we now possess. Moral significance begins, and does not end, with suffering. The presence of conscious experience, above all the capacity to feel pain, distress, or deprivation, is the most direct basis for moral consideration. That is why debates about animal welfare, clinical care for disorders of consciousness, and the oversight of research that manipulates subjective states so often hinge on questions of sentience. But moral thought must also accommodate other values that matter for persons: flourishing, agency, autonomy, the integrity of identity, and the capacity for meaningful relationships. Conscious beings are not mere repositories of pleasure and pain, they occupy perspectives that can be harmed, honored, misunderstood, or enhanced. Ethics therefore requires plural sensitivity, attend to suffering, but also to agency, dignity, and the narratives that make lives intelligible. One basic conceptual distinction is between moral patients and moral agents. Moral patients are entities whose good we should consider. They may lack full autonomy or culpability but still deserve protection: infants, many animals, some patients with severe cognitive impairment. Moral agents are beings capable of moral reasoning and responsibility. That distinction helps organize policy, protect patients from harm, hold agents accountable in proportion to their capacities. Yet the line is fuzzy in practice. Many humans who are partly impaired still exercise agency in important domains, and some animals display forms of agency relevant to moral assessment. The prudential response is graded ethics, fasten rules that scale with evidence about capacities while guarding against the temptation to oversimplify. This graded approach finds an analogue in epistemic humility. Our tools for detecting consciousness, reports, neural markers, behavioral tests, are fallible. Wrong classifications have moral weight. Falsely judging a being to be unconscious may lead to neglect and harm. Falsely ascribing consciousness could impose burdensome obligations or misguided interventions. Given uncertainty, a precautionary principle is morally defensible. When the possible cost of error is severe, inflicting avoidable suffering, give the benefit of doubt to minimizing harm. But precaution must not become paralysis. We ought to couple precaution with proportionality, weigh the plausibility of consciousness, the magnitude of potential harm, and the consequences of action or inaction, and design policies that minimize expected moral cost. Clinical ethics is where these abstract principles meet the concrete. Consider patients with disorders of consciousness, vegetative states, minimally conscious states, locked-in syndrome. Decisions about life-sustaining treatment, pain relief, and experimental interventions hinge on whether a patient is likely to have subjective experience and how much their life aligns with their prior values. Here the moral toolkit includes surrogate decision-making guided by advanced directives, careful use of convergent neural measures, repeated assessments, and a conservative deployment of irreversible interventions. When modulation can restore or enhance capacities, for example, stimulation or pharmacology that can return responsiveness, the burden of proof for limitation becomes high. Conversely, interventions that alter a person's core values or sense of self require special caution and, where possible, prior consent. The ethics of enhancement is a public frontier. We already have interventions that change mood, memory, and attention. As tools become more powerful, their social distribution and normative consequences matter. Enhancing memory or attention could widen inequality if available only to the privileged. It might change what counts as fair competition in education or employment. There is also agonizing nuance. A person with chronic depression might welcome memory dampening of traumatic episodes, others might worry that such changes hollow narrative identity. A responsible policy stance recognizes human pluralism, permit voluntary enhancement under rigorous consent and safety regimes, restrict coerced or deceptive uses, and cultivate public deliberation about social norms so that enhancements do not unfairly impose new burdens or erode shared institutions. One of the most philosophically knotty domains is identity, what it is to remain the same person over time. We intuit that certain changes are permissible within a continuous life, aging, acquiring new beliefs, recovering from trauma. But radical changes caused by neurological intervention, personality shifts after deep brain stimulation, memory erasure in hypothetical future therapies, or algorithmic rewiring in an advanced brain-computer interface, test our intuitions. Ethically, we must weigh well-being against identity. If an intervention improves welfare but alters traits that constitute someone's core projects and relationships, is it net good? Part of the answer is procedural. Ensure that interventions that risk identity-altering outcomes come with robust informed consent procedures, second opinions, and, where possible, reversible options. Where consent cannot be obtained, surrogate decision-makers should weigh preserved values and the likely quality of the changed life against the benefits of intervention, erring on the side of preserving the person's dignity and previously expressed values. Criminal justice is another area roiled by neuroscience. Brain states provide new information about culpability, reduced responsibility, and rehabilitation prospects. The discovery that a person acted under impaired volition due to a brain tumor or intoxication can appropriately mitigate punishment. But a wholesale neurodeterminism that denies agency threatens to erode moral responsibility and social order. Philosophers and legal scholars often adopt a compatibilist stance. Responsibility is preserved if the agent's capacities for rational control and social understanding survive, even if those capacities are themselves products of causal processes. Practically, neuroscience should inform sentencing, treatment, and rehabilitation, not replace normative judgment. That means using brain evidence to design proportionate, humane sentences that prioritize public safety and rehabilitation while respecting rights. When it comes to animals, ethical policy has already been evolving in many jurisdictions, but the science of consciousness should push it further. If organisms exhibit behavioral and neural markers plausibly tied to valenced experience, then their welfare should count in legal and institutional decision-making. This has implications for factory farming, laboratory research, habitat destruction, and conservation prioritization. Ethically, we should favor procedures that minimize suffering, promote flourishing where possible, and respect the ecological systems in which conscious beings live. Importantly, comparative cognition reminds us that welfare should be attuned to species-typical needs, enrichment and care that suit a primate differ radically from what an octopus requires. Moral imagination must match cognitive imagination. Artificial intelligence raises many of the same questions but folded into new shapes. If we are building systems that might in principle be conscious, prudence recommends 3 layers of constraint: precaution in creation, ethics by design, and governance by oversight. Precaution in creation means institutions, funders, and regulators set thresholds before systems with architectures plausibly related to sentience, for example, high degrees of integrated information, robust metacognition, or sustained valence signaling, are scaled or deployed widely. Ethics by design means architects should avoid designing systems that could suffer without safeguards, incorporate mechanisms for graceful shutdown, constraints on training that produce suffering-like states, and logging and transparency so external auditors can evaluate system states. Governance by oversight demands independent review boards, interdisciplinary ethics committees, and legal frameworks that treat suspected conscious systems with caution while protecting human interests. Attribution of moral status to artificial systems is difficult. Functional parity is not sufficient for attribution in practice. We should require multiple converging indicators, evidence of integrated subjective-like processing, continuous developmental history that grounds preferences, capacities for pleasure and pain analogues, and some form of irreducible first-person report or reliable behavioral proxy. Even then, moral attribution should be gradual, governed by the strength of evidence and practical considerations. The cost of being wrong, causing suffering to a conscious system, justifies conservative protections. The cost of unnecessary restrictions, failing to use benign tools, suggests proportionality. Both costs must be weighed publicly and democratically. Privacy, autonomy, and mental liberty are ethical poles in the age of brain and AI technologies. Neurotechnology can reveal or alter preferences, memories, and intentions. The right to cognitive liberty, the freedom to think privately, and the right to decide which mental interventions one undergoes, should be shielded by legal norms. Consent must be informed, revocable, and not coerced by power asymmetries. Data from neural recordings should be protected as sensitive personal information with stringent safeguards. Employers, governments, and commercial actors should be restricted from exploitative uses. There is a civic dimension too. Public conversations about acceptable uses of neurotechnology should be inclusive, transparent, and ongoing. Democratic governance, not techno-solutionist secrecy, should shape policy. The distributional dimension cannot be ignored. Technologies that modulate consciousness, restorative or enhancing, will have unequal access along socio-economic lines unless actively democratized. That inequality can widen existing disparities. Those with resources may gain cognitive advantages, improving life prospects in ways that entrench privilege. Ethically, societies should pursue models that balance innovation with equitable access. That might mean public funding for therapies that restore function, regulations to prevent unregulated commercial enhancement that entrenches inequality, and public deliberation about what values we want technologies to promote. Research ethics present special challenges. The history of science has sordid chapters where vulnerable populations were exploited in the name of knowledge. Contemporary researchers working with interventions that affect consciousness must adopt strict safeguards, robust informed consent, independent ethical review, risk-benefit analysis that contemplates subjective harm, post-trial support for participants, and transparency about conflicts of interest. Special protection should apply when subjects are populations with diminished capacity, children, cognitively impaired individuals, incarcerated populations. Institutional review boards should include ethicists, patient advocates, and subject matter experts who can appreciate the phenomenological stakes. Education and public engagement are moral tools as much as legal devices. Ethical choices about consciousness technologies are too important to be left to technocrats. Citizens need access to clear information about what is possible, what is uncertain, and what trade-offs are on the table. Deliberative forums, public ethics councils, and participatory technology assessment can help societies decide which directions to encourage and which to constrain. These processes are not mere outreach, they are epistemic resources that surface values, fears, and priorities that technologists often miss. Finally, the moral temperament we should cultivate is not merely precautionary but also imaginative and reparative. Precaution guards against harm, imagination asks us to understand the inner worlds of others and to design compassionate systems, reparative thinking commits us to remedy wrongs that arise from past ignorance. This temperament recognizes the dignity of subjective life, respects the frailty of our knowledge, and refuses neat moral panics. It embraces layered policies, protect vulnerable minds, regulate powerful technologies, support equitable access to therapies, promote public deliberation, and hold open the conceptual space for revision as evidence accumulates. Consciousness is a biological and philosophical fact, but it is also a moral touchstone. How we answer questions about whose experiences count, how we alter minds for better or worse, and what limits to place on our technologies will define the character of our societies. This chapter does not offer juridical statutes or final moral truths. It does offer a framework of humility, precaution, proportionality, and public participation. Those are the virtues most likely to keep us from treating minds as mere resources and most likely to invite a future in which the power to shape inner life is matched by the wisdom to protect it. Chapter 14 of the book so far has been a slow accretion of vantage points, cells and circuits, computations and qualia, evolution and experiment, ethics and society, then this chapter is an attempt at synthesis without pretense. Synthesis here does not mean declaring a triumphant final theory, it means sketching how the parts we have surveyed might be productively held together, how research programs can be organized so that competing ideas are tested against one another, and how the intellectual virtues of humility and rigor can coexist with aspiration. It is a chapter about maps and expeditions, what the map should look like if it is to be useful, and what kinds of expeditions we should undertake next. A productive integrative stance begins with pluralism that is principled, not eclectic. The phenomena of consciousness, unity and multiplicity, immediacy and narrative, bodily feeling and social extension, are diverse, different theoretical tools illuminate different facets. Some frameworks are best at explaining why certain neural patterns produce flexible behavior, global workspace-style explanations. Others excel at formalizing unity and irreducibility, integration measures, and others offer powerful process-level accounts of perception as inference, predictive processing. None of these is prima facie eliminable by conceptual reasoning or empirical refutation, they instead make different claims about necessary and sufficient conditions, about mechanisms, and about phenomenological correlates. A sensible synthesis treats these frameworks as potentially complementary levels rather than as monolithic rivals. Our task is to specify how these levels should map onto one another, which formal measures correspond to which mechanistic actions and which phenomenological signatures, and under what conditions a particular level can be privileged. Operationally, this means building a research program with tight linkage among levels. A fruitful cycle begins with a phenomenological insight, a careful, disciplined report about the texture of experience, that yields a concrete hypothesis, that hypothesis is rendered computationally explicit, that computational account suggests measurable neural signatures, those signatures are then perturbationally tested, results feed back into revised phenomenological questions. Neurophenomenology is not a slogan here but a method, first-person descriptions and third-person manipulations must be yoked to one another in iterative experiments. For example, if a subject reports a qualitative shift in self-boundary during a specific practice, a good experimental program will operationalize that shift in terms of temporal coherence, network coupling, and behavioral indices. It will predict what happens when certain nodes are perturbed, and it will return to subjects to refine the phenomenological categories the moment the data show unexpected patterns. A multi-scale modeling agenda is indispensable. The brain is not a single-scale machine, it is a collection of interacting hierarchies. Models that connect ionic currents and synaptic dynamics to circuit motifs, and that in turn embed those circuits into network architectures that implement prediction and broadcast, are required. Those models must be computationally explicit and falsifiable, they should be simulable, produce measurable signatures at each scale, and be open to perturbation. Such models will be hard to build, but the payoff is high. They will let us ask whether certain microarchitectural hypotheses are merely epiphenomenal or whether they can causally influence mesoscale dynamics in ways that change phenomenology. This is the only route by which disputes about substrate sensitivity versus functional equivalence can be turned into empirical questions. Experimental arbiters must be chosen with care. Contradictory claims about the role of frontal networks versus sensory recurrent loops for conscious content, for example, are not resolvable by rehashing intuitions. We need experiments designed to separate access-related activity from phenomenology per se. No-report paradigms, perturbational approaches that transiently disable candidate nodes, and decoding techniques that read content independently of overt report are part of that toolkit. At the same time, we should be wary of over-reliance on any single method. Convergent validity, where multiple, independent techniques point to the same inference, is the gold standard. A proposed signature of consciousness that survives correlational, causal, and cross-species tests deserves to be taken seriously. Comparative and developmental studies will be especially illuminating. If consciousness is multiply realizable, then identifying the minimal organizational motifs across diverse brains gives us an empirical handle on necessary conditions. Conversely, developmental trajectories within a species show how integration, prediction, language, and social scaffolding accumulate to produce the kinds of complex phenomenology humans report. Longitudinal studies that follow neural and behavioral markers across early life, aligned with refined phenomenological interviewing, will tell us which capacities are foundational and which are culture-dependent elaborations. Comparative work across taxa, cephalopods, birds, mammals, and perhaps social insects in carefully structured experiments will reveal whether the same computational motifs recur in systems with widely different implementation details. If similar information integration profiles predict similar behavioral indicators of awareness across these species, the evidence will favor function over substrate. If not, we will need to refine our concepts. Artificial systems are the laboratory of philosophical possibility. They force us to operationalize our definitions. What does it mean in practice to instantiate integration, global broadcast, metacognition, and valence? Engineers can design systems that meet those formal criteria, and we can then examine whether those systems exhibit behaviors that, under our comparative standards, merit ascription of some moral consideration. Such projects should be pursued under ethical guardrails, small, controlled systems designed to probe precise hypotheses about organization rather than to leap to full-blown synthetic persons. If machines that satisfy a family of converging indicators begin to show robust signs of something like valenced processing, the ethical consequences will follow and must be anticipated now. Building these systems will not merely inform metaphysics, they will make practical decisions unavoidable. Theory must be richer in predictions and stingier in hand-waving. Good theories tell us what evidence would count against them. For instance, if the global availability hypothesis is central, it should predict patterns at the macroscopic scale that are altered whenever broadcast is interrupted without destroying local processing. If IIT is correct in stronger forms, its measures should generalize across substrates and predict degrees of consciousness in systems humans do not typically think of as minds. If predictive processing underwrites the phenomenology of surprise and the felt sense of agency, pharmacological or behavioral manipulations that selectively alter precision weighting should alter specific phenomenological dimensions in predictable ways. Lacking such falsifiable predictions, theories remain metaphoric. The field must reward models that produce crisp, risky predictions amenable to real experiments. Methodology must become more integrative. Multimodal data collection is the baseline, intracranial recordings where ethically and clinically possible, combined with surface electrophysiology, metabolic imaging, behavioral assays, and subjective report. Perturbation, reversible, minimally invasive when applied to humans, must be integrated into causal tests. Statistical methods should account for non-stationarity and individualized dynamics. Consciousness is not a stationary property distributed uniformly across people and contexts. Pre-registration, open data, and multi-site replication must be normal practice, not exceptional. Science of consciousness will mature only when robust effects survive the crucible of replication across labs, techniques, and populations. Ethics must be embedded into the research program, not appended. Institutional review boards and funding agencies should require explicit consideration of the potential for inducing suffering or altering identity in studies of consciousness. Experiments on non-human animals must meet strict welfare criteria commensurate with plausible stakes for suffering. Work with artificial systems must include protocols for auditing internal states and for shutting down systems in safe ways if harm-like states are suspected. Public engagement, transparent discussion of aims, methods, and possible harms should be routine. The point is not to constrain science for its own sake but to align its aims with broadly shared moral commitments. Science that studies minds has moral consequences that demand proactive governance. Policy and law must begin to catch up in principled ways. The chapter on ethics sketched a graded and precautionary stance. Now we need institutional machinery, standards for assessment of disorders of consciousness that require convergent evidence before life and death decisions, regulation for neuromodulation devices that can alter personality or agency, rules for corporate use of neurodata that treat neural signals with the privacy protections akin to medical records, and international norms for the design and deployment of advanced AI. Architectures potentially able to instantiate sentient relevant organizations. These are large tasks and will require interdisciplinary teams, neuroscientists, ethicists, lawyers, technologists, patient advocates, and citizens deliberating together. Education matters. To steward a future in which we can manipulate and perhaps create forms of consciousness, societies must cultivate broad public literacy about what consciousness is, what the evidence says, and what the ethical stakes are. Schools, media, and civic organizations should host dialogues that are neither technophobic nor technocrat privileged. A democratic society cannot delegate the fate of minds to a narrow class without forfeiting its moral responsibilities. Teaching should include not only scientific facts but also conceptual tools, how to reason about evidence, how to weigh uncertainty, how to apply precaution thoughtfully so that public policy is informed by reasoned consent rather than fear or hype. What of the deep unresolved questions? The explanatory gap persists as a conceptual knot. Even a fully articulated multi-scale model that predicts and manipulates experience will leave some philosophers unsatisfied. There may be limits to explanation that are cognitive rather than scientific, constraints on human conceptual schemes that make certain relations appear miraculous. That is an epistemic humility to internalize. Progress in consciousness science will not necessarily make the hard problem vanish from human pondering. It may, however, reshape the question so that what once seemed like an unbridgeable chasm appears instead as a boundary between levels of description, a boundary we can cross in practice even if the metaphysical verdict remains contested. Practical futures bifurcate into many possible worlds, and our choices matter. One plausible trajectory is an ethic and evidence-guided stewardship, careful expansion of therapeutic tools, transparent governance of neurotechnology, equitable distribution of benefits, strong animal welfare protections, and slow, deliberate experimental creation of artificial instantiations only with robust audit and oversight. Another, darker path is hurried commodification, neurotechs used for exploitation, rushed deployment of architectures without ethical guardrails, and a market race that privileges profit over reflection. Which path unfolds depends on institutions, public deliberation, and scientific culture. The argument of these chapters is that the responsible path is not only morally preferable but scientifically wiser, cautious, reflective progress preserves public trust and yields better data. There is room here for wonder that is not naive. Understanding how patterned activity in membranes and circuits gives rise to the vividness of taste, the ache of grief, or the clarity of a mathematical insight is a bold project. It is also, crucially, an ethical one. Each advance will change our diagnosis of suffering, our ways of treating illness, our moral circle, and even our self-understanding. That is why the enterprise must be collaborative across disciplines and across society. Let me close this chapter with a pragmatic checklist. not because checklists are glamorous, but because they help translate aspiration into action, commit to multi-scale, testable models, prioritize convergent methods and perturbational tests, expand comparative and developmental research, build ethically-centered governance before scaling interventions, fund interdisciplinary training that combines neuroscience with ethics, law, and public engagement, require replication and openness, and cultivate public deliberation around the stakes of creating, modifying, and attributing minds. These items are neither exhaustive nor sufficient, but they form a scaffold on which a mature science of consciousness can be built. We do not finish here with final answers. We finish with a practice, the disciplined curiosity that honors both the undeniable reality of inner life and the realities of the physical systems that sustain it. A scientific temperament that prizes risky predictions and robust replication, and a moral attitude that treats minds, human, animal, or machine, as sites of value deserving of thought, care, and cautious stewardship. If we can hold those practices together, we will have matched intellectual rigor with ethical seriousness, and that may be the most we can, and should, ask for as we continue to probe how consciousness arises and what it asks of us. Chapter 15. If there is one practical moral of the whole inquiry, it is this: consciousness is neither a single thing nor an inexplicable miracle, it is a relationally and historically instantiated process. It arises in materials that have been shaped by selection, development, and culture. It depends on architectures that enable integration and flexibility. It is altered by the contexts in which organisms live and the languages they use to reflect upon themselves. This is not a modest claim in consequence. It means that answers will not be found by a single method or a single discipline. They will be found by a patient weaving of conceptual clarity, experimental ingenuity, technological care, and moral reflection. The right kind of progress will be collaborative rather than triumphalist. At a conceptual level, the last chapters have already sketched the anatomy of a defensible synthesis, treat competing theories as complementary descriptions of different levels, insist on precise, falsifiable predictions, tie phenomenological reports to rigorous experimental design, demand convergent validation across perturbation, recording, and decoding, and place ethics at the center of priority setting for research and applications. To this architecture, I would add 3 commitments that should guide the next generations of science, policy, and public life. First, a commitment to multi-scale mechanistic modeling. If consciousness is a process that spans ionic channels, dendritic compartments, recurrent microcircuits, whole brain networks, bodies, and social scaffolds, then our models must do the same. This is not merely a technical aspiration, it is a normative requirement. Single-level accounts risk mistaking correlation for explanation. A theory that links microstructure to meso- and macrodynamics and that yields concrete, testable predictions about perturbations will be strong science. Building such models will be slow and expensive, but it is the only real road to transforming the hard problem into a tractable engineering and philosophical program. These models should be open, modular, and auditable. Other teams must be able to reproduce, challenge, and extend them. Second, a commitment to empirical humility and methodological pluralism. The history of consciousness research is littered with attractive metrics and seductive findings later revealed to be context-dependent or conflated with report-related processes. We should treat candidate markers, late frontoparietal ignition, PCI, various measures of complexity, as provisional tools, not final verdicts. No single marker will capture all the richness of experience across species and contexts. The best strategy is triangulation. Use multiple independent assays, including no-report paradigms, pattern perturbations, decoding, and first-person methodologies. Replication across laboratories and species should be standard. When results disagree, treat the disagreement as an opportunity to refine the question rather than as a failure of science. Third, a commitment to ethical foresight. The capacity to detect, modulate, and perhaps create conscious systems transforms not only epistemic practice but the moral landscape. We must not wait for crises to build governance, we must design institutions now, interdisciplinary ethics boards, public oversight mechanisms, protocols for precautionary shutdowns, and international agreements about practices that could unintentionally create suffering. At the same time, ethics cannot be merely prohibitive. It should be generative, funding research that aims to relieve suffering in animals and humans, investing in equitable access to therapies that restore function, and designing AI systems with built-in auditability and safeguards. Morality, in this domain, is not a constraint on curiosity but a condition for its legitimate pursuit. Beyond commitments, there are intellectual and practical frontiers that deserve special emphasis. One is the comparative project, richer, more systematic studies across taxa. The ecology of nervous systems is vast. Cephalopods, birds, social insects, and mammals provide natural laboratories for testing whether integration, broadcast, prediction, and metacognition co-occur with behavior we plausibly associate with subjective life. Comparative work should not be an exercise in anthropomorphic projection, it should be an empirical program that marries careful behavioral assays with neuroanatomical and network analyses sensitive to the particularities of each species. Another frontier is developmental neurophenomenology, longitudinal studies that combine neural metrics with fine-grained reports and behavioral assays as cognition and selfhood unfold. These studies can reveal which capacities are foundational and which are cultural elaborations, thereby informing interventions that promote flourishing from the earliest stages of life. A third frontier is the minimal substrate question: what is the simplest organization sufficient for a non-trivial form of experience? This is a risky, ethically fraught line of inquiry if pursued casually, because it brushes up against the possibility of creating beings with experiences we cannot easily assess or ethically justify. Nonetheless, done under stringent oversight and with clear humane aims, for example, understanding pain to reduce it in other animals, targeted, small-scale experiments can yield crucial insight. They will require transparent protocols, independent review, and an ethical bar higher than that used for studies that do not touch subjective experience. Artificial systems deserve a separate word. They are our handiwork and our responsibility. The likely near-term reality is not sudden creation of human-like minds but gradual increases in capacities that bear on morally relevant properties, more robust internal models, richer value-like systems, even if currently instrumental, and greater autonomy in decision-making. Each incremental advance should be accompanied by commensurate governance, red team evaluations for potential suffering-like dynamics, design constraints to avoid needless valence analogues, and legal frameworks that treat opaque black box systems with suspicion. At the same time, AI can be an ally. Well-designed artificial agents can assist in diagnosing disorders of consciousness, in augmenting communication for locked-in patients, and in modeling complex dynamics in silico that inform ethical biological experiments with fewer animals. The dual role of AI, tool and possible locus of moral status, demands careful stewardship. We should also cultivate a public epistemic culture that refuses both naive scientism and paralyzing mysticism. The public deserves clear, honest communication about what we know, what we do not know, and where the uncertainties lie. Scientists and institutions should resist the temptation to overclaim. Trust is built by transparency, by acknowledging limits, and by demonstrating ethical seriousness in practice. Public engagement should not be reduced to PR, it must be dialogic and deliberative, giving communities voice in shaping research priorities and in setting thresholds for societally consequential experiments. Philosophy retains an indispensable role. There will always be conceptual knots that empirical work cannot shortcut. Clarifying terms, detecting category errors, and refining the logic of arguments are all tasks best done with philosophical rigor. But philosophy should be tethered to evidence. Thought experiments have power as probes, not as final judgments. They should push empirical hypotheses. If Mary seems to gain something on seeing red, what neural or computational difference accounts for the novelty? If zombies seem conceivable, which background assumptions are at work, and how might they be tested? Philosophy best serves consciousness science when it generates precise questions whose answers can be sought in the lab and the field. At the level of lived meaning, this inquiry about other minds folds back on our own attitudes. Knowing more about how consciousness arises should not shrink our appreciation of the mystery, it should deepen it. The discovery that subjective life emerges from processes we can model and manipulate is not a reduction that impoverishes value, rather, it is an invitation to stewardship. If pain is a signal, we can refine our means to alleviate it. If selfhood is a fragile construction, we have reasons to protect it. Knowledge gives us power. With knowledge comes responsibility to use that power to reduce suffering, to enhance flourishing, and to protect the conditions in which persons, in all the varieties that warrant respect, can live meaningful lives. We end, not with a declaration but with a posture. Approach consciousness with curiosity that is exacting and with humility that is proactive. Pursue theories that make risky predictions and then test them under diverse and ethically attentive methods. Design technologies that respect mental privacy, that limit unnecessary harm, and that distribute benefits equitably. Cultivate public institutions and educational practices that can host the hard ethical conversations before emergencies force rushed judgments. Recognize that our concept of a mind will change as we learn. Be ready to revise legal categories, moral duties, and social practices as evidence accumulates. Above all, do not let the difficulty of the hard problem foster intellectual resignation. Rather, let it be the discipline that teaches us to ask better questions, to demand better experiments, and to act with more compassion. As a final image, imagine a long table around which many people sit: neuroscientists, philosophers, clinicians, ethicists, engineers, artists, and citizens. Around us are instruments and notes, graphics and stories, argued papers and quiet reports of lived experience. The conversation at that table is not a contest but a collaboration. It proceeds by the stubborn method of joint attention, by attending together to the same phenomena from different angles, by aligning repertoires of attention and by negotiating shared meanings. The aim is not to conquer the mystery but to be worthy of it, to develop explanations that are scientifically robust, to design interventions that are morally defensible, and to live in societies that treat minds with the respect their fragile unity deserves. If this book has offered anything useful, it is that, a set of lenses, a posture, and a set of practical commitments for an inquiry that must remain open, rigorous, and humane. The end of this chapter is, therefore, not an ending but an invitation to study, to care, and to steward the many forms of subjective life with patience and moral seriousness. The question, what is consciousness and how does it arise, will keep calling us forward, and how we answer will shape what kind of world we make, for ourselves and for others.